Secret police. Ladies and gentlemen, good morning. Welcome to the parallel session 2-3 here, Solutions to Non-Electric Energy Demand, including Hybrid Energy Systems. I'm very happy to see you here. So although there are a couple of people stealing our chairs, so thank you to the audience of attending here in this difficult to identify room. Thanks to Josef to mobilize a little bit the signage here, so that's fine. So thanks to the audience, thanks to our panelists here, and I hope we will have an interesting, engaging discussion this morning. Well, my name is Michael Fütterer from the European Commission's Joint Research Center. I spare you my bio. You can look it up on LinkedIn if you want to. I'm very happy to have my co-moderator, Alexis Amacri, here from Women in Nuclear, Young Generation. And we are also happy to have Stéphanie Cornet here as our rapporteur, and we will introduce to you in a minute in more detail our 6 panelists.
Distinguished ladies and gentlemen, thank you all again for joining this session. My name is Alexis Amacri, and I am representing the Women in Nuclear Young Generation, as well as the French Society of Nuclear Engineers Young Generation. And I will, in no particular order and very quickly, introduce our panelists, our esteemed panelists here, starting from Michele Frignani. So Michele is the head of nuclear technologies and product development at Ansaldo Nucleare in Italy. He covered multiple roles in the company, from technical coordination to management responsibilities of increasing complexity, and is now supporting the strategic plan, including the interface and synergies with the companies of the group. Michele has a PhD in nuclear engineering from the University of Bologna in Italy, and recently attended the Key Manager High Education Program by the CDP Academy. Thank you very much, Michele.
Thank you.
Next, I will go to Nicola Rega. Nicola is the Executive Director, Climate Change and Energy at CEFIC Belgium, where he represents the industry's interest to European institutions, international organizations, and relevant stakeholders. His main areas of expertise are energy and environmental policies. Nicola has a master's degree in law from the University of Turin an advanced master's in political and social European integration from Vrije Universiteit, Brussels, and a Master of Law in Energy and Environmental Law from KU Leuven. I think that's in Belgium as well. Okay. And next, I will introduce Dr. Paul Nevitt. So Dr. Paul is the Vice President for Science and Technology at the United Kingdom National Nuclear Laboratory, and is also responsible for leading the overall UK NNL Clean Energy Strategic Focus Area. He currently serves in various capacities, such as the United Kingdom Government Delegate and Vice Chair of both the Generation 4 International Forum and the OECD Nuclear Energy Agency Nuclear Development Committee. As the chair of the Global National Laboratories Integrated Energy Systems Collaborations, also as a member of the governing board for the EU Sustainable Nuclear Energy Technology Platform, SNETP, and a member of SNETP Nuclear Cogeneration to Industry NC2I Coordination Board. As a member of the International Fusion Technical Advisory Group, FTAG, for the UK Government, Department of Energy Security and Net Zero, and also as the UK Working Group Lead for the US and UK Civil Nuclear Research and Development Action Plan on Enabling Actions. Paul is a fellow of the Royal Society of Chemistry and the Nuclear Institute. So I'll hand over to Michael for the rest.
So just as an explanation, we go into a little bit of a detail in the bios of our speakers because they are success stories. And I think especially for our young generation people, I think they are all good examples how you can make your way in nuclear in a very successful manner. So our next success story is Slavica Ivanovic. So happy to have you here as well. Born in Podgorica in Montenegro, Slavica has dedicated her academic and professional career to energy and nuclear engineering. After completing high school, she received a scholarship from a Greek ministry to study electrical engineering in Thessaloniki. And upon completing her master's degree there in power engineering, she pursued a second master in nuclear energy. She spent the first year of her studies in Barcelona and the second in Paris. Then she began her professional career at the French INSTN, where she spent 6 years working as a lecturer and researcher at a research reactor. She then transitioned to the private sector, where she took on responsibility of leading techno-economic studies in the nuclear sector, safety studies, research reactor design, reviews, license documentation audits, and studies for the European Commission. She made a significant contribution to the Kalogina project, and those of you who have paid attention, it was presented also at the SMR Alliance. It's an innovative small modular reactor concept for district heating, and there she has been actively involved for 2 years. Today, she's employed by Tractebel in Belgium, and she's an SMR project innovation lead. Her role involves defining strategic priorities and key functionalities of digital solutions, coordinating multidisciplinary teams, and ensuring the successful execution of project management. She actively monitors developments in the SMR market and emerging technologies, assesses client needs, and contributes to multiple projects aimed at advancing the nuclear industry through sustainable and innovative solutions. So, thank you for being here. Then we have Josef Sobolewski. Josef Sobolewski obtained his Master of Science in Physics at the Warsaw University and a PhD in Physics at the Mainz University in Germany. He received also an MBA from Warsaw University of Business. He has over 15 years of research experience in nuclear physics at research institutes in Poland and Germany. He has worked for over 20 years in IT corporations in various managerial, business development, and sales positions. And last year, Josef also held high-level positions in the Polish Ministry of Energy. Currently, he is the Plenipotentiary Director for High Temperature Reactor Development at NCBJ, one of the organizers and our hosts here, and he has held some positions in European organizations. He is a member of the Euratom Scientific and Technical Committee, a member of the governing board of SNETP. He's also the chair of the Nuclear Cogeneration Industrial Initiative, and he's vice chair of the Nuclear Safety Working Group at the SET Plan. So thank you also to Josef. And our final panelist is Stefan Sarade from CEA. He's the director of energy programs there and graduated as a biotechnology engineer in 1989, biotechnology in nuclear. He got his PhD in chemical engineering in 1994 and specializing in supercritical fluids and membranes processes, and he has a habilitation in research management as well. He joined CEA in 95 and then was successfully head of laboratory, head of service, and head of department within the nuclear energy division. He managed R&D programs in chemical engineering applied to decommissioning, decontamination, reprocessing, and nuclear waste management. Since 2020, Stefan has been director of the Energy Program Direction, a strategic direction within CEA dedicated to low-carbon energy R&D programs, including nuclear and renewable energies, where more than 2,200 employees are involved. In parallel, since 2006, he has been the chair of Supercritical Fluids Innovation, a non-profit organization devoted to green processes. He has also, since 2011, been the research director of CEA in chemical engineering and green chemistry. And more recently, he was re-elected in 2024 as a member of the board of SNETP, and in early 2025, that's brand new, he was appointed as the chair of the Generation 4 International Forum for the next 3 years. So thank you all again for being here. I appreciate also how shall we run this discussion panel today. So we thought that every one of you, according to the list that we have here and the series, everybody will make a short statement, a few minutes. You have prepared a few slides for that. We know that you can be punchy, to the point, and very convincing, and I put a challenge to you to try and demonstrate that again in the session this morning. And yeah, so we begin with Josef Sobolewski. Is that, you want to take over?
Yes, and please remember, if you have questions, you can write this in the chat, or you can just keep it for when we ask the audience questions. So I invite Josef Sobolewski, please, the floor is yours. A round of applause for him, please.
It's working? Okay. Thank you. I like to stay and, of course, see what is the in the presentation behind, but I hope that is visible. Okay. Very shortly, because I was asked to present the Polish case as our way to this what we are now. We are now in with some basic concept or basic project of the HDR reactor, small reactor. But how it was? It started for me in 2016, where I was the director of the Nuclear Energy Division in the Ministry of Energy. That's coming to me as some people. I say, okay, we should find the solution for the Polish industry. The Poland is still is a very industrial country, and we have a lot of chemical, petrochemical industry, and that was the question to find the solution for them to decarbonize this sector. And there is a huge sector, as you see here, the 13 largest chemical plants have 6.5 gigawatt needs of heat. For heat means in this moment between 450, 500, but generally it's about 550, 560 degrees of Celsius. And this was some target for us to find the solution. That was some special team that was established in Ministry of Energy. The chairman was Professor Wrochna. And after 1 year, they put some report that was a possibility for deployment of high-temperature nuclear reactors in Poland. And at start, it was not decided which reactors. We only know it should be high-temperature reactor. But of course, the results of this one-year work with a lot of people from industry, from financing, from security, also from regulators, observer, and of course the scientists, that was the decision that the most mature and available technology is high-temperature gas-cooled reactor. This was the decision we should go in this direction. And of course, that was still some needs for explanation for the political decision maker. But we have some argument like the decreasing dependence of fossil fuel imports, mostly gas in this moment from Russia. Of course, that is also decreasing the sensitivity of our economy on the changes in the climate policy. This is very important. And this time when we are having this report, the ton of CO2 costed €8. Now it's 10 times more or more. And of course, the synergy with our big program, the program for a big power plant for electricity generation. And that's our way for this. It was some program that first was that was necessary to find a partner, because to develop some technology take dozens of years sometimes, and we wanted to do this in shorter time. And we choose the Japan colleagues from Japan Atomic Energy Agency because they have a HTTR in Japan, 30 megawatts prismatic high temperature reactor. And it was some basis for us. But is it basis? This solution that we projected, that what we propose now, is in 50% Polish solution. It's not a copy of Japan solution, it's 50% is Polish solution. And first, of course, we have some agreements between also on the governmental level. Then next, we have some small project from the Polish National Center from Research and Development that was related to, to prepare some, we say, environment for deployment of high HDGR related to law, organization, and technical instruments. It was quite successful, small project for 20 million Polish zloty. And in 2021, we started, for us, a little big project related, that was sponsored by the Polish Ministry of Science. And the project that was the technical description of HDG gas-cooled high-temperature research nuclear reactor. It is a research reactor, but for us it's also the demonstrator of technology. We want to develop in this moment the technology and the supply chain based on the European solutions. Okay, on the right side you have a very short about this reactor. It is thermal power is 30 megawatts. It's prismatic core. The most advanced now in the commercialization is Pebble Bed in China, but this is in China. And this is graphite moderator, helium coolant, triso fuel, very important because it's very secure reactor. There is no possible severe accident in this reactor. The core melting is not possible, quite simple. And the outlet temperature, we choose 750 degrees. The Japan version have a 950, but we decided that we need for industry. The Japan thinking about the helium production and the thermochemical splitting. We are thinking more about the decarbonization of industry, and we don't need so high temperature. And this is, of course, the question of cost and technology. And, of course, we want to have the cogeneration means that now is very interesting, the story, the polygeneration means the heat for district heating, heat for industry, electricity, of course, if we don't need too much heat, and the hydrogen production in splitting processes, not in electrolysis. Of course, we can also electrolyze in high temperature, but there is also interesting opportunity for thermochemical splitting of water. How is the situation now? In Poland, we have the basic project of the HTTR Pola, the small reactor. It's technical documentation, high-level technical documentation, over 3,000 pages. He is the boss of this project. And we have also two supporting projects sponsored by Euratom. It was Gemini Plus and Gemini 4.0. There is still not finished, but it will be finished this year. There is an on-closing phase. In this project, we developed the European version of commercial reactor, I can so say. And this is important because, of course, that this European version will be 180 megawatts thermal power. It's bigger than the demonstrator. And, of course, we want to involve the European countries for the future development of this commercial version. But it will be based on this, what we have now in Poland, the basic project of Pola. And you see here why is that so very important. On the picture above, on the right side, you have a different needs for temperature for different industries, and comparable to this what we can reach in the nuclear. The light water reactor, 300 degrees and full stop. And high temperature reactor here is, of course, for 950. This is Japan version, our is 750, but this is enough to cover the needs of a lot of industries. Decarbonization, don't forget, now in Europe, if you are looking on the energy using per capita, that is 70% is fossil fuels, is whole industry and transportation. And there is electricity is only 24-25%. Yeah? This is area that is still full to decarbonize, and we have maybe some solution, maybe. On the right side here, you see the needs for in terawatt hour per year for the heat industry heat, and you see here, of course, this what we are trying to reach is this 250-550 degree. Because then is the empty place, and over 100 degree is something for the future maybe, or for the hydrogen production. And the most important, we decided now to pass our project in the Industry Alliance. You know Industry Alliance, you have here a lot of presentation about this. And we started now with our project in cooperation with Framatome, a French company. We started to try to develop the project working group for high temperature. We're using the name high temperature industrial heat, but it will be based on the HTGR reactors future European version. Thank you.
Thank you very much. If you have specific questions, please indicate on the chat that you have questions for Josef. So next, I will invite Michele to give us a 5-minute presentation on Ansaldo. Thank you.
Thank you. Thank you. So first of all, a few words about Ansaldo Nucleare. Ansaldo Nucleare is an Italian company with an international footprint, with a strong engineering background. However, we are not just provider of engineering services. We take the risk of EPC contracts mainly through joint ventures, international or national joint ventures with manufacturers and civil works companies to deliver full EPC contracts. So this risk translates into capitalizing experience that we then redevelop into new technologies and new products, and that is one of the strong points of Ansaldo Nucleare in the current energy market and nuclear supply chain. Sorry, I was on the wrong slide. Then one small note about the Italian context. As you probably know, Italy was one of the pioneers in the nuclear industry at the very early stages, but then after 1986, Italy decided to phase out from nuclear. So mainly for the last decades, our domestic market was driven by decommissioning and waste management activities on existing sites. However, recently Italy decided to reconsider the option of the nuclear energy, and in the current plan for national energy policies, we have an input of potentially up to 8 gigawatt electric, corresponding to 11% of the Italian energy demand in 2050s. This is mainly driven by stability of the network and reduction of infrastructural costs in Italy, but actually the comeback to the nuclear then raised attention also by industrial users and industrial associations. Italy, as you can see in the map, has quite a wide distribution, which, however, is not uniform across the country, and there are also regions which are more polarized towards a specific industrial activity, like, for example, in the north, steel making and forging activities. In the center, near Tuscany, there is a strong footprint for a pulp industry. There is ceramic tiles in the Bologna area, and so on and so forth. So the geopolitical crisis and the rise of gas prices recently raised concern about security of supply and stability of the price, but also in terms of competitiveness on the industrial sector. So this has, as I said, raised attention and interest in the industrial associations, which now look at nuclear for providing not only electrical energy, but also thermal energy to those industries. In terms of our, as Ansaldo Nucleare, our involvement in European projects and European activities concerning the cogeneration or the other energy uses for the nuclear industry, we've been working closely with NC2I, but mainly we started with the SNEP+, which for the first time analyzed the potential of medium energy markets for fast reactors. More recently, we have been involved in the Tandem project. We have made a survey within Work Package 1 of the technologies to be included in a hybrid system with the nuclear reactors, and also in MFICO. MFICO is more related to coupling nuclear reactors of current generation with electrolyzers, so it's not using that much the thermal input, but actually made quite an extensive analysis of the safety issues and the regulatory framework for the coupling of nuclear and hydrogen production. However, I want to point out also another project, which is Anselmus, where there is a specific work package devoted to other energy uses. Anselmus is related to fast reactors, and in particular lead-cooled fast reactors, and then in that project we decided to focus on medium energy applications for this technology. And as you may have heard, Ansaldo Nucleare is leading an initiative which gathers other research centers across Europe, in particular Enea from Italy, Ratenna ICN from Romania, and SCK-CN from Belgium, to develop the EU SMR LFR, and has been shortlisted among the first 9 projects within the European SMR Industrial Alliance. This project will be very much oriented to the customer, so we are trying to collect the needs of the industries and the utilities across Europe. We are launching very soon an end-user advisory board in order to promote our initiative, but also get feedback on what is really needed by the industrial market and the energy market in Europe for the next future. As a last point, I wanted to share with you a case study we launched. We analyzed how SMRs could contribute to the steel industry. Actually, Italy is the 11th steelmaker industry in the world and the 2nd in Europe. We therefore try to understand how nuclear power could be used to decarbonize the steelmaking industry, focusing on the primary steel first. We considered a conversion of current technologies into the so-called DRI, which uses as an input hydrogen instead of gas, and we tried to hybridize the system where nuclear power could feed electrolyzers. Electrolyzers need, of course, at medium temperature, high temperature, needs, of course, water. So we also coupled the desalination plant to produce that water. And of course, the secondary steelmaking part requires a lot of electricity through the electric arc furnace, so the nuclear reactor could also deliver electricity for that purpose. In the end, this was an interesting case study, but however, if we look at the Italian context, for example, we have only one primary steel maker in the south of Italy. Everything else is based on recycling scrap metal. So For those industries, it will be much more interesting, for example, having fixed price electricity for long-term use, and then try to decarbonize all the secondary, let's say, part of the production of steel, where they will for sure need heat at medium temperature, for example, for preheating processes, or improving the efficiency of some of the steelmaking industry processes. Thank you.
Thank you very much. Now we will invite Nicolas Rieger for his presentation.
Thank you. And does it work now? Can you hear me? Yes. Hello, good morning, and thanks for the invitation to be here. Just a few words from my side. CEFIC represents the European chemical industry. The ones that are not familiar with the industry, is the largest industrial energy consumer in Europe. And we are an energy-intensive industry. We are competing globally. At the global level, we are the second chemical manufacturers in the world. We are ahead of the US, behind China. What does it mean being second in the world? Well, if you take the top 10 producers and you accumulate the production of all the 9 runner-ups, together we don't make up with the volumes that China is producing. So being second is good, but the environment in which we are operating is extremely challenging. And that's why the impact of energy prices is one of the key elements that we are addressing in terms of competitiveness, and this is one reason why I'm here today. If I can just drive you through, we are the largest, I would say, the largest energy consumer. We are topping up on all fuels that we are consuming. So we are the largest gas consumer. We also are the largest electricity consumer. In terms of electricity today, we are roughly consuming 160 terawatt-hour of electricity, which is, I was checking this morning, it's equivalent to the total consumption of Poland. So just to get a bit of a feeling of the relative weight in which we are. And we'll be looking at different options moving forward. What could be a scenario in which we can also further electrify the energy use where we are not using electricity, so going to steam production and to see how far we can go. And well, the graphic shows different scenarios, but fundamentally we can go, we can increase potentially the amount of electricity that we are using for energy purposes by a factor of 2 to 4, depending on what scenarios we are looking for and what kind of technology mix we might be considering. Now, this being said, electricity, it's an interesting concept, but from an end user perspective, it comes with a high cost. High cost compared with where we are today because of all the accumulation cost of not only the production, but also the network fees, charges, the taxes, and everything else. I was talking yesterday with one of our CEOs. He was saying, well, if I look at my bill, 2/3 are non-energy components. So if we could already start reducing that part, would be good for my competitive element, but of course, cost somewhere needs to be allocated. So that's why we've been looking at SMR, because we see that there are a lot of projections in looking forward, and electricity prices don't seem to go downwards in any scenario. So we are expected to continue having high electricity prices from the grid, and that's where the potential of having SMRs as an on-site energy production, it's something which starts becoming quite interesting. It would be kind of, for us, it's a cogeneration 2.0 in a way. But it's also a matter of understanding for the ones that are already using electricity, whether that could be also an option for reducing the electricity bill by reducing the exposure to network grids and tariffs and taxes. So that's a bit of where we are, why we start engaging on the SMR discussions, and what does it mean for us. So As I was mentioning, on-site is what we are looking for. Of course, we are interested we are looking also on how nuclear develops across the network grids and how that contribute to reducing energy bills. But fundamentally for us, it's a matter of on-site possibilities. Now, I know that for many of let's say the electricity industry, it is difficult to cope with industrial consumers because we are all different. Every site is different, every sector is different. But this is also what we see that with the SMRs, we have also an opportunity of getting closer to some sort of standardization of the product that could also help scaling up the production also from the electricity industry side. We're also looking at options where these SMRs is working also in the context of industrial clusters. And that is something that for electricity, for our chemical side is quite normal. We live in microcosm of industries around us. That also helps scaling up the size of this energy production and also how to accommodate different uses across a segment or different segments of industry clustered together. We also see that there are interesting potentials for having a different type of relationship between energy suppliers and energy consumers, given that the skills required to operate an SMR are not the skills that you find in industrial sites. So there is also possibilities to have a different type of partnership also from a commercial point of view and operational point of view. Now, this being said, there are also a lot of issues that we need to go through. One of them is when we start approaching SMRs, we thought that SMR was a technology, but actually it's a number of different options on the table, and we need to find exactly the understanding of what is there that is fitting for the needs of industry. And then again, our industry is already by itself quite differentiated, let alone when it comes to multiple industrial needs. Also, time is an essence, because the economic crisis in which we are going through is not making these discussions any easier. So we are in kind of urgency to find solutions, and having the message, the typical message that don't worry, the technology will be there in 10 years' time, is not the one that our members are prepared to listen to. So we need to have a perspective that things are moving and we can have something as soon as possible. Now, also, this being said, we cannot just afford to wait for technology to be there and then start thinking how we deploy them, because there are a lot of regulatory issues that needs to be sorted out, especially if we start coupling nuclear installations next to industrial sites. So there is all sorts of issues linked with the permitting, with liability, with everything else that needs to be sorted out together. So in our case, we have done a little bit of our homework. When you see the slides, you also go on our website. We have done 2 papers, one looking at the potentials of SMRs for our industry. We've been actually mapping out all our industrial sites on the petrochemical side and on the chlor-alkali business. These are 2 different businesses. One, the petrochemical, where you can see as SMRs to switch fuel from gas to electricity, and chlor-alkali because it's an electro-intensive process. So what could be, and we've been mapping them all out, so you know exactly what kind of temperature needed, what are the capacity needed, so you have an understanding of what could be done. And we also done another paper looking at the regulatory framework. And now, as a last point, as a chair, myself, chair of the SMR Alliance, the working group on end users, we also move in these discussions also across sectors. So we're trying to do this kind of mapping also across other energy-intensive industries with data centers and also with the maritime industry to provide as much as possible information to the nuclear industry in understanding what do we need, what is the size so that we are talking about, what kind of demand we have, so that at least we can try to standardize as much as possible the demand so it makes your life easier. Thank you.
Thank you very much. Just before I invite the next speaker, I would like to emphasize that we would appreciate this session to be very interactive. So if you have questions after the presentations, we're open to take questions. Now I invite Slavica Ivanovic for her presentation. Thank you.
Test. Is it working? Is it? It is. Yes. Okay. Hello, thank you very much for joining this panel session. Thank you very much for invitation. Yes, sorry, I see it here, but not there. Okay, so I'm coming from Tractable, and it's been more than 8 years that Tractable has been looking at the promises of small modular reactors and investing thousands of engineering hours into technology deep dives, into due diligences, work that was done for different technology developer as well as industrial clients. We are still convinced that SMRs are absolutely the cornerstone of tomorrow's energy ecosystem. And we see the tomorrow's energy landscape relying on hybrid energy systems that will bring the solution to challenge of energy sustainability. As today's topic is non-electric application, I would like to mention that industrial clients that we are working with and learning from at the same time, that was mentioned before, because these industries are not used to work together, come from different sectors. So there is chemical, petrochemical, mining. We even worked we work for a district heating company, and also we explored the integration of SMRs for data centers and mining activities. I will share at the end of this presentation, let's say, global trends that we have noticed while working with industrials. And yes, I would try to be brief, so to leave some space for discussion, which is way more interesting than talking about numerous projects. So in addition to work with industrials and vendors, we have been working with Euratom research and development projects. Some of them were already mentioned. The tandem is led by Tractable, which is exploring the integration of light water SMRs into hybrid energy system of European Union. And then as well, super interesting project Gemini 4, which is building on Gemini Plus and exploring, showing how we can actually in safe and economical way produce hydrogen, as hydrogen is needed for industry, because SMRs cannot always produce high temperature steam. And it's looking at it's preparing as well the high temperature gas cooled reactors for licensing, also mapping out the fuel supply chain plan, and also preparing stakeholders in engagement plan. All these projects, Euratom funded projects, you can see them in the other room on the panels. They are described as we don't have time, and I suppose that most of you are pretty much familiar with them. So my key takes away from our studies that we are doing with industrial and cogeneration, the general trend is that industrials have very high expectations in terms of time schedule and cost of energy, where one impacts the other. As we are doing a lot of economic assessments, levelized cost of electricity and levelized cost of heat estimations, we have noticed that one of the important parameters is weighted average cost of capital, which is the yearly average the company is expected to pay for its assets. So if you have an increase of 1.5%, it can have a huge impact on LCOE. Going to even 35%, which is not the case for other parameters in this economic assessment. So what can be done? Well, the risking could be done through innovative business models, which means involving from early stage off-takers into the project of SMR, and this could de-risk the project and accelerate the time schedule. What we also noticed is that through energy, through grid, that we could also do grid balancing through integrated energy storage, and this could as well increase substantially the revenues. Very important thing is that for first-of-a-kind SMR to be a success, no matter what industry we're talking about, is to have an alignment of all the stakeholders from the very early stage. Because as I said before, and they are not familiar with all the challenges that nuclear is bringing, and we are also learning about their processes and how we could decarbonize. For example, in September, I believe, we will publish a white paper on decarbonization of refineries. So over there, we are proposing an incremental approach, so going from systems that need the least engineering to the ones that are way more complicated and require innovation, and that would be hopefully possible, but solutions are not available today at industrial scale. So yes, and finally, of course, there was a lot of talk about this during last few days. So policymakers play a very important role. So all the taxations and subsidies are absolutely shaping the market and pushing certain designs more than others and giving space for small modular reactor development. Well, that's all. Thank you.
Thank you very much. I will now invite Dr. Paul Nevitt for his presentation.
So thank you. I think we're all in agreement, aren't we? So we can all go home. Nuclear is the solution. So I think we've moved on a long way. These panels, I think, we were trying to convince folks a few years ago that nuclear was part of the solution. I think we've made that argument. I think the discussion that we'll try and get to is how do we accelerate? And they're the key questions that have just been set out, is that people want to know when and how much. But I'll give you a UK context. What's happening? What are we doing? And what's the questions that we're doing? And I'll explain some of what we're doing at the National Lab, but I'll keep it at a high level from a UK perspective. So again, you can map this in any which way you want to. The goal, whether it's energy security or decarbonisation, we in the UK have a net zero goal by 2050. We have clean power, clean electricity by 2030, which is the current UK government target, which is extremely challenging. But electrify where you can. Let's try and get off reliance of fossil fuels, reduce emissions. So electrify where you can. But the problem being, and in the UK context, it's exactly the same, is there's parts that you just can't electrify. So what do you do with those parts? And how do you get to that solution? And is nuclear part of that solution? If nuclear is not part of that solution, what is the solution? How do you accelerate carbon capture? How do you accelerate the alternatives around that? So we want to be part of that solution as nuclear. In terms of UK context of nuclear, what are we doing? Government is committed to progress large, small and advanced nuclear. Large, small, mainly focused on electricity generation. Clearly, if you electrify, electricity demand increases hugely. You need to decarbonize. Nuclear is part of that. We expect announcements in relation to Sizewell C, the next large reactor, in June, and the Great British Nuclear SMR competition in June also, in terms of the next stages around that. But government has also committed to advanced modular reactors in terms of really around what you do around the non-electric parts and those hard-to-abate sectors in the UK. And the story is very similar to how, and what Joseph set out in Poland. Because of the UK context, a few years ago, the government did an assessment of what's the right advanced technology from a UK context to focus on. The decision came to high-temperature gas reactors based on UK experience of gas reactor technology, experience of graphite-moderated reactors. Also, in the UK context, the most mature technology that could deploy at scale to decarbonize by 2050. There wasn't a consideration around fuel cycle closure and recycle. So from a UK context, I must reiterate, a UK context, high-temperature gas reactors were chosen as the advanced reactors as preference from a UK government, but they were clear to not rule out support to other reactor technologies over the longer term. And actually at the UK lab, we work on all of the technologies. So in terms of advanced modular reactors for high temperature heat, what's happening? Government do two different things. They have something called the Future Nuclear Enabling Fund, which they've provided investment to, for example, X-Energy. to progress their technology, but they've also set around the Advanced Modular Reactor Research, Development and Demonstration Program to target a demonstration system by the early to mid-2030s, and that's where the relationship between UK NNL and JAEA came in. And just to reiterate, why did we partner and work with JAEA? For exactly the same reasons as Joseph, building on operating experience of high-temperature reactors of the HTTR in Japan to develop a design for a 200-megawatt thermal reactor, around 750, maybe a higher temperature, but with a UK context. I guess the bit to point out on the design is that, in really little writing, is the smart manifold. And that relates to my last slide, is that the engagement we're having with industry. So as part of the program, government wants to know what's the demand from industry. And you've heard, it's very similar in the UK, as you've heard around, is yes, please, but when and how much is the question. Industry has to produce a product, we know that. It has to be a commercially viable product, so they need to know how much the energy is going to cost. And they have plans to continue making their products, so they can't wait for decisions, so they want to know when. In this context, why a smart manifold? There's, to some extent, the end user engagement we've had is there's reluctance to be a single owner of nuclear assets. They would rather be a part of taking supply. So this cluster mapping, which you see in the UK cluster, how do we decarbonise the clusters? This is one in the northeast of the UK. There's around 24 users there. The majority, 50% of the energy need or heat demand is below 300 degrees. But there are demand above that and interest in nuclear. Why this area of interest as well? So we're working with EDF and Momentum on this, and EDF has an operating advanced gas reactor, Hartlepool, which will come to an end of life in the not too distant future. It has space on that site. How do you transition those people working on that reactor system to future work? Can you get the transition to future energy in that space? So for me, I just leave you, I guess, from a UK context, the question from industry and the energy intensive users is when and how much.
Thank you very much. And finally, I will invite from the CEA, Mr. Stefan Serrad.
Thank you very much. I don't know if you can see the slides. Thank you very much, ladies and gentlemen. Good morning, and thank you for joining this panel, and thank you for the organizer for inviting me. Just for the young generation, I'm not pretty sure that my first wife and my second wife would qualify my professional life as a success story. But I did my best, and the major point that you have to take into account that for 30 years, I had and I still have a lot of fun with a lot of colleagues, a lot of friends, and that's perhaps the most important. And we go further with, for instance, Michael or Paul. They belong to the GIF leadership team. And then we are fully concerned for the future, because fourth generation means for us the future. I belong to CEA, which is a European RTO, a public organization in charge, in part of the research and development in low carbon energy, either nuclear or renewable energy. And that's very important because our vision is we have to produce low carbon energy. And that's the point. And the question is how to combine those topics. So in terms of context and challenge, a lot of things were previously given. So I will keep the English vision, the KISS vision, keep it short and simple. You have to take into account that the non-electric energy demand in Europe is 2/3 of our energy demand, which is fully carbonized. And of course, it includes heat, district heating, industrial heating, transport fuel, and so on. So those sectors are obviously harder to decarbonize because it's difficult to transfer heat on long distances. It's also, in case of industry, you require high level of temperature. For the third generation nuclear plant, you can achieve maximum 300 degrees Celsius, but in fact, you can use manage 150 degrees Celsius. And for the fourth generation system, you can achieve up to 800, 900 degrees Celsius. That's the reason why when you apply to district heating or industry needs, it's totally different. And in terms of energy density and storage for heat, for instance, you need a lot of things. So we have to, and within CEA, we support the deployment of a new energy system where nuclear system can both provide electricity and heat. As a public RTO in France, our mission was and is to support the 11 newcomers, new startups emerging through the call for tender France 2030. And it's interesting because those newcomers, they all include more than electricity in their solution. That's very important. So in Europe, Euratom is supporting R&D in this area, and that's very important to go further in this field. So hybrid energy system, how to integrate nuclear system with other energy sources. Small and advanced modular reactor, for me, SMR, small modular reactor, 3rd generation, and AMR, advanced modular reactors, 4th generation. And the major, in terms of heat, is the level of temperature that you can apply. But there is, of course, application for all those range of temperature, from district heating up to industrial needs. And I will put an emphasis on desalination, because perhaps in our world, we will have to face the lack of potable water before the lack of energy. So producing potable water, and in this case, you need electricity and you need heat, low carbon heat for that. It's very important. We had some example on steel makers, on chemical companies, on cement plant. So we have a lot of possible end users interested in this field. And we also had hydrogen in our scope. Why? Because coupling SMR or AMR with steam, high temperature steam electrolysis that we designed within CEA with our joint venture with Schlumberger, the name is Genvia. We produce such kind of electrolyzers. The idea is to produce low carbon hydrogen using the system. And we try to go further, because if you've got low carbon electricity, if you've got low carbon heat, then you can produce low carbon hydrogen. And therefore, if you are able to capture CO2 by direct air capture or something else, you can make what a chemist like me like to make is chemistry, hydrogen and CO2, methane, methanol, ethanol, ethylene. That's for chemical compounds, and you can go further up to sustainable aviation fuel, e-kerosene, and that's one of the major plans for R&D in our work. So we have an active, within CEA, we have an active role in Euratom demonstration project. We try to push the deployment of new demonstrators able to answer the question given by Paul, how much, when and how much we will be able to deploy in this field, and other possible support for the discussion. Of course, policy and fundings are critical in this field, because we have to develop a system able to help us to achieve a large level of scale-up for that, because we are talking with industrial people. So more than demonstrators, how are we able to manage the scale-up? Cross-sector and working in different fields with different kind of end users, with different kind of needs is very important. And in my personal point of view, that's very enthusiastic, because it opens the range of activities more than nuclear activities. We have to face all the other field. So, of course, technico-economics assessment of hybrid system are very necessary. It was mentioned previously. We have to raise the awareness across all the fields of industry of the potential of the use of such system. Within Europe, we have to support pilot projects, and for that we need money, and we need money also for industrial demonstrators. And we have to put and to integrate those strategies in our national and the European strategy in order to achieve, with the good kinetics, the deployment of our roadmaps. So in terms of Euratom involvement, we have to expand the R&D focus beyond electricity, more than electricity, for all the applications we mentioned. We have to foster the cross-sector collaboration, and we have this opportunity in Europe to work on that together. And we have to integrate hybrid system in the strategic roadmap. And I think that our discussion will perhaps help us to achieve a more relevant roadmap in this field. Thank you very much.
So thank you very much, Stefan. Thank you to all the panelists. You have given us a very intense flavor of what is ahead. I think we have heard about, also for your benefit, of course, we have heard a lot about the market. We have scanned the horizon across different countries, across different industries. We have heard about the chemical industry, the steel industry, the maybe e-fuels and other applications of nuclear, the desalination, huge market, of course. Now, the market is there. We have been knowing this about this now for more than a decade, for sure, even more. We have also worked on a lot of technologies to actually satisfy these markets. And thanks to some Euratom projects that we have also heard about, I think we have also found a couple of solutions how to deal with this market. That's technology is only a part of the solution. And some of you have already spoken about how to actually get there. We have, and I see Frederik Reitzmer here from the IAEA. The IAEA has written a report a few years back that said that nuclear cogeneration has like 750 reactor years of experience worldwide. So there is quite a bit of experience available, but it has sort of slept in. And why has it slept in? I think part of the answer is that fossil was simply too inexpensive for the moment. It's too easily accessible, and it was the solution for the day. Now we have to think a little bit further, and beyond the technologies and the market, we need to think about how to put everything to work, how to put this puzzle together and actually get there. And I think in the beginning, in the first session here at the forum, the conclusion was actually deliver. No, it was yesterday in the SMR Alliance presentation, it was deliver. And I think also here with the non-electric energy demand, we have to start to deliver. And in this context, we have prepared a few questions on subjects like market, finances, policies, and technologies. And I think we would like to have now the opinion on a couple of subjects related to that. How can we actually make it happen? How can we use the insights that we had on the 4 topics that we will address in a minute to actually move forward and industrialize with the help of research organizations, but also with industry and policymakers and other stakeholders, regulators were mentioned a number of times. How can we get there? Right. So let me maybe start the discussion just by a quick step backwards to the market, and that's a question for Slavica. What do you think about, well, from what you have learned through your own activities, through your involvement in Euratom projects, and maybe also from this panel or other discussions, what would you think is the first market for small modular reactors in non-electric applications?
Okay, I'm afraid I might be a bit biased in answering this question because I have what, in my opinion, what's like the least challenging, and that would be definitely district heating, because here it's hard to compare like district heating reactors with, let's say, reactors that are 300 megawatts and they are to provide high temperatures. If you look at the price of those, we are talking about 150 million per 1 unit, which will be, let's say, a demonstrator, while where we are talking about first of a kind for like reactor that will serve for cogeneration and with higher power, we are talking about billions of euros. I think that the 3 designs that are currently in Europe are sufficiently mature in order to be first, if they have a proper support, of course, because we know that they need a lot of investment and in order to push it until the first of a kind. But this might be a bit biased. At the end of the day, of course, no one knows who's going to, what project will be the first. And we see that if you look at all the SMRs, all startups that were mentioned recently, they all have different budgets. They all have the investments they managed to gather during past year, like are really different. We're not the same order of magnitude even. And the investments, if you look at the US, like this is again another scale. For example, their Department of Energy is investing more than 1 billion, for example, only in TerraPower. But we don't have this kind of investment on the other side. So it's difficult to know, but in my opinion, it would be the really, let's say, the least challenging for district heating.
Okay, thank you. So you're on low-hanging fruit. You want to grab it quickly. Michele, you have another idea?
I think. Can you hear me? Yeah. I think I fully agree. Actually, district heating is 12% of the energy demand, and so it's a huge market. However, district heating is also a reality now and from many decades because there are nuclear power reactors that are already supplying district heating in Switzerland, in Sweden, many examples also in Europe, as well as desalination. Also, desalination has been coupled to nuclear power plants. There are examples in Russia and so on. So I think that these applications have a market, but we also to consider that the market, at least in Europe, is not homogeneous. I mean, district heating is something that is looked for in many northern and eastern countries, while less perceived as a need from the market in other countries like Southern Europe. So I agree that is the quick win in terms of cogeneration for the nuclear power, and we should look for it for sure. Any technology can provide basically district heating because LWR, large plants, small plants, but also any other kind of technology generation will be able to do it.
Wait for a second. For a second. So thank you for that. I just want to point out that district heating also has problems. It's a low-hanging fruit, that's true, but it's also an economic challenge because of the, say, seasonal dependence of the customer. So this is why I would like to switch directly to Nicola before we come to Josef, because you mentioned that the chemical industry has huge demand. It's also mostly 24/7 consumption. So I wonder whether, compared to district heating, a chemical application is maybe not the economically more viable first solution. What do you think?
Thanks. I definitely don't want to start a competition who is like a beauty contest. But certainly I understand that there are some elements in there that like with the district heating, you have certainty of the customers and you can spread costs across generations and understand it. What I'm trying to push through the industrial dimension is something a bit different that I hope it helps also creating the kind of standardized market demand that industry from the nuclear industry requires. Let me explain this. I've been working on this electrification for many years, also working for the power sector in the past, and we always remember there was always the issue that when we talk about electrification in other sectors, vehicles, everybody understands what is a vehicle and how does it look like. Heating for houses, everybody has an understanding what are the 2, 3, 4 options out there. When you talk to industry, it's a black hole because you don't know what it is, and it requires a lot of ad hoc auditing and engineering design specific. And we don't have this luxury in moving forward with the decarbonization agenda on the front, with the international competition. We're not going to rebuild any industrial site. So the modularity of the SMRs, what is interesting is how we can go into some sort of, and I apologize for all the engineers in the room, but I'm not an engineer. I talk with politicians. So the concept of the Lego brick approach, where we can build different modules, and then we can stock different units across. That is something extremely useful as a concept, which creates a large demand for modules that can be then stacked up. Let me explain you also. We have one of our members who is investing in an SMR in the US, and we've been discussing with them how did you come up with this idea. And the issue was that they were saying we need 1 gigawatt of capacity. And if we would just go for one module for gigawatt, then because our key issue is to produce, we need to make sure that there's always continuous production. So if you would like to have this certainty, then we need to have another 1 gigawatt of capacity for backup in case of failure, system failure. Now, with the modules, they went for 4 modules of 200 megawatt, 5 modules of 200 megawatt, and then they have only 1 module of 200 megawatt as a backup. That is a fundamental paradigm shift in the way we are approaching this interaction between the nuclear energy industry and industry, because then we start having a scaling up of those smaller modules that can be stacked together. And then that brings different dynamics also in terms of how do we see the use of electricity in industry, because we go from a narrative whereby by moving towards more electricity use for energy purposes, we would potentially create an additional baseload demand for the grid, which means bigger liability in terms of consumers for the grid, because we are expanding the demand towards a system where we are, again, we are maximizing the cogeneration concept of benefits, and then we have also backup unit, the backup unit that then can also help the network at the times of need, so in reversing the flows. So there is a total different dynamics, which also, I feel, brings a total different discussion also in terms of business case and interaction between the energy industry, not only the suppliers, but also the ones that are going to operate, so the energy companies that will be operating these sites. And it's true that households are more resilient than industry in terms of long-term planning. Yet, even if in case of failure, there is still a demand out there. So there is still, the asset will not be lost. So there is a possibility of having interactions between the two sides of the coin in a way which is, I would say, beneficial for both sides.
Thank you. Before I ask you a provocative question, I wanted to let Josef speak in a minute.
Yes, I want to say something very short. It's simple. I will be happy if I can deliver the high temperature heat to chemical industry, but it takes time. Sorry. What we can doing now, what we can have. We are now delivering the heat for district heating from nuclear reactors. What we need to develop the small reactors, put them easy to the cities and deliver this. The technology is done. Only please do this. And by the way, we have in Finland a process for the LDR-50 reactor. This is water reactor. That is developed for only district heating purposes. They want to build them. They started to licensing this. That will be probably the district heating at the start will be the first place when the heat, not electricity, will be located. Because it's running now, it is quite easy. And by the way, you know, the biggest heat network in Europe is in 2 countries, Poland and Germany. I don't suggest that you go with nuclear reactors to Germany. Come on, I don't like to say this. But to Poland, no problem. Yes? And that is, I think, the answer. District heating will be the first, because it is now. Thank you.
Okay, thank you for your point of view. My provocative question that I promised you a minute ago was, many of you have talked about the market. The market is huge. We talk about hundreds of gigawatts. That means also hundreds, if not thousands, of reactors, depending on the size, of course. And now people who are critical to nuclear, they say, the market is so big you will never make it because it requires so much investment. You will be never able to rake together all the money needed to even satisfy a fraction of the market. What would be your reaction? Is that wrong? Is that a good argument? Is it a wrong argument? What can you, what can we do to actually make cogeneration happen? And this is why I wanted to ask now Slavica for a minute. Why do you think is nuclear and especially nuclear cogeneration attracting still so little attention from investors, and how can that possibly be changed?
Why is it attracting? You mean like in here in Europe? Yes, because, well, I think we all know the answer to this question, because nuclear doesn't have such a favorable place in taxonomy. I think one of the reasons it doesn't attract investment because in Europe the situation is there is not, we don't have as such so developed private capital like in the US, for example, and longer time scales for project development, of course, and then lack of visibility on prices, on the future prices. This can be assured with power purchases agreements. But also in our experience, what we saw, all the industrials that go for cogeneration, they are very cautious because in order to, let's say, when you do the technology down selection, you are down to few reactors that might fulfill the need of your industrial. There has to be a lot of investment that is coming in that you might also decide at some point to stop the project. So there is also huge risk that is at the very beginning of the project. So this is one of the reasons that they are very hesitant to continue with it. And so this would be, yes, I think this would be my opinion. I think that there should be, we should have like tax credits, incentives that would like give a nuclear more favorable position and make it, if not equal to renewables, then give it like similar rights. But I would invite as well the other panelists to comment on this, because I'm not an economist, I'm an engineer, but this is what I could notice, yeah.
Both first?
Yeah, so I think we also need to raise this up a level. It's not just a nuclear conversation. So if we agree we're going to go for decarbonisation, energy security, coming off fossil, okay, if we agree that's the goal, nuclear is a subset of that goal, but it's part of the goal. And if I give you a UK context, so we've done system assessment of and the demand for nuclear heat. So even if the options for decarbonisation of industry, even if you deliver the most biomass and hit all of your carbon capture, you will still need in the region of 2 gigawatt of heat from nuclear. So that's even if you deliver everything at highest optimization of the other technologies, you still need that. That's in addition to 10, 20 gigawatt of nuclear for electricity and nearly 100 gigawatt of wind for electricity. So your challenge is, how do we deliver the system, and nuclear is part of that system, and how do we get to the scale of thinking that we need to and be part of that conversation? I think that for me is a key challenge, because for delivering at scale, it's how do you achieve that overall goal, and making sure that nuclear is part of that overall assessment. I think in terms of the scale of the challenge is not just nuclear, and how we deliver, many of the skills needed to deliver and the supply chains will be common across other technologies as well. So I think that for me is an important aspect. We still need to make the case for the role for nuclear, but then it has to be part of the wider discussion. And that's where we get into in the UK context, is it's that system assessment, and how nuclear is part of that system assessment. So, but it's a massive challenge, you know, and we've got to accept it's a massive challenge.
Yeah, I think we all agree on that. Let us maybe dwell a little bit more on the question of financing, because it's at the interface between industry, investors, end users, the public, etc. Maybe, Stefan, I don't know, do you have some insight how France is envisaging to tackle that problem?
I don't think we have the solution. Just I wanted to say that I fully support the comment of Paul, and I just want to say that the question you answer, is nuclear ready to answer, is not a good question. Obviously, it's always the same topic, because the good question is: are we facing climate change? Are we facing CO2 production? Do we need low carbon energy? And then you can answer. I'm pretty convinced that we don't have the luxury to say this one is good, this one is not good. And that's a big shift we saw in nuclear activities for the last 5 years. It was what Margaret Thatcher used to say: if you are not a part of the solution, obviously you may be a part of the problem. And for years, nuclear was not considered as a solution. And the shift we saw in terms of public acceptance, and I think producing heat for district heating with nuclear is very interesting, because when I was working in Russia in 2000, in Siberia, district heating was provided by the nuclear power plant. And we could survive because of that. So it's not a new solution. It's a solution that was developed in Russia, which is now developed in China, in new scale. So the idea is, okay, we have to shift the public acceptance in this field. And the energy dependency, and since 2022, what did happen in Ukraine also increased the interest of, okay, what are the possible options? And I will not say that nuclear is a solution, but nuclear is obviously a part of the solution. And for that, and to convince that, we have to find fundings, and you mentioned that in US, our ARDP funded $1.6 billion for the deployment of newcomers, of new startups. I think that one of the success we can learn from the success in terms of, are we able to combine private and public funding? And that's what we try to do in France, within France 2030, the call for tender, with several hundred of millions euros, just in order to stimulate emerging newcomers. And we have 11 companies that get money, and we are entering new phases. And of course, the amount of company will decrease, because now we are entering in some phases where the company will need more money in order to deploy demonstrators and deployment for nuclear safety. And therefore, I don't have the magical solution, but I think we have to learn how to combine public and private funding, especially when we are in, the TRL zone between 4 to 6, the Death Valley, where we need to deploy, we need to finance, to fund demonstrators, and academics say, okay, it's not for me because it's a demonstrator, and industrials say, okay, it's not for me, it's not for industrial, it's only demonstrators. So we have to find how to pass this Death Valley, and I think that Europe and Euratom, with funding new facilities and helping us to achieve scale-up studies on those facilities, should be very important.
Slavica?
Yes, I just wanted to add something quite important, I think, on this topic. I think that there is low risk tolerance when it comes to institutional support in Europe. In a sense, we are very much focused on incremental research and development, but we're not focusing the first of a kind, a demonstrator, and this is what's happening in the US. I think that we have a lot to learn from them. I've been traveling lately for events, and I think both cultures have to learn a lot from each other. But in any case, in this when it comes to financing, I think this is very important, and we also there is a lack of unified strategy in European Union, in the sense that we haven't mentioned this, but there are still countries that are strongly anti-nuclear. But things change, and this is not a really nice, not really favorable for private investment. In a sense, now I hear that even like there are American companies going to Germany to do walkdowns in their nuclear reactors to see if we can restart them and so on. So things change. Belgium is also a really good example of how things change during how strategy.
Okay, let me come back to the question of financing again. So some of you have pointed out very different, a few ideas where we have to go, the avenues that you have to walk down to actually make something happen. But the question really is, do we have all the structures in place in Europe, and do we have enough money to actually make it happen? I'm not convinced that this is the case right now, especially the instruments. Are they really suitable? I would like to have your view on, for example, what was presented by the SMR Industrial Alliance, the IPCEIs that you have heard about. Do you think that these are the right tools to make things happen, and not happen only maybe in the long term, but fast? Because speed is also decisive, not only because we need urgency, we have some urgency to find solutions, but we are also in a very competitive situation, for example, with China or the US. I think Paul was first, Stefan, and Michele.
So as the UK rep on this panel, I won't comment on EU kind of approaches, because that would be completely inappropriate.
Not yet.
However, I'll try and answer your question in a different way. Do we understand the mechanisms and structures of how to finance large projects and projects? Yes, I would point people in the direction of, for example, the recent OECD NEA report on financing case studies from September, just published. Great example of structures and things. The key bit from that report and from assessments of how you structure is where's the balance of risk through the project, and where does it sit, and how do you make it right for the right entities? And knowing that projects involve multiple entities, you need to know where the balance of risk is. And the key conclusion also from that NEA report, and I'd encourage people to read it, is government have a key role in it. So I think that is, what stage your project are at, where's the risk, is the balance of risk right, and are you incentivizing the right people to attract? If you want to attract private investment want to know you get a return on that investment. So you need to construct the finance. But I would recommend the report, and again, as I say, I won't comment on the EU.
Please know that at the EU we are always very grateful for external advice. Thank you so much. Stefan, you were next.
Yes. I wanted to go further with the example of the US, because it's a very quite liberal country. And after the 1.6 billion of EURADWASTE, when you see where are the first of the kind and who financed the first, and you can see that very quickly, national laboratories for the first of the kind, defense application for the first of the kind, and very recently, last year, the GAFAM, because they have a huge needs of energy and a huge amount of money. Okay, so that's very interesting that to see that the government and defense put a lot of money in order to finance the first of the kind of those first reactors, and others, those people who have a lot of needs. In France, the request from the data center for 2030, their request is 8 gigawatt, 2030. Just remind you that 6 EPR is 10 gigawatt. You can see the large amount. So, of course, we have to have this discussion. But the question of Michael was connected to the financing and what happens. You know, the SMR Alliance, it will be a success, in my opinion, if we succeed in the KPIs. And we have a lot of presentation of the agenda and so on, but where is the money? Where is the funding? I don't have a really good view of where is the funding. A work package is devoted to think about how to finance, and I think that's very important, and it will be very important to see the final achievement they can suggest. I am perhaps more confident to IPCEI, because nuclear IPCEI means that members state members will put money. And therefore, we'll be sure, and we have this example for the IPCR on battery, on hydrogen, on electronics, countries, members say, okay, we put money on that. And then we launch the call for tender. So I think that it will be a very interesting initiative that we will have to follow in order to combine funding, interest of the state, and combination, because that's the point of IPCI. You can fund either public or industrial partners. And perhaps it will be one of the solutions.
Thank you. Okay, we could dwell on that discussion a lot more. Also, for your information, there were at the SNETP General Assembly, there were presentations on what an IPCEI actually is. It's an important project of common European interest. For those who are interested, you can look it up on Google, and you see what has already been achieved with this type of tool. But Michele wanted to intervene on finances as well.
Just very few points. I don't have an answer to your question, but SMR Industrial Alliance in TWG8 made an assessment of the available funds right now at European level, and because of many different reasons, some of them are specifically for SME, some of them are excluded by treaties, some of them are for high TRL innovations. So there are very few instruments right now that are potentially supporting first-of-a-kinds or low TRL innovations, and we hope IPCI will solve this. However, the timeline is not very short. I mean, the bureaucracy and the process that is behind the public funds in Europe is quite cumbersome and takes time. So now we will be in the process of nations, different member states, ministers collecting proposals, and then proposals will move to the next phase. So we need somehow, the policymakers need somehow to streamline these processes and make them easier.
Excellent and a very essential message. I think our rapporteur is already writing this down. Josef.
I think we have nothing in Europe that can support the nuclear now. Sorry, for the folk, we have no possibilities. And maybe IPCEI will be some option, but that will be option that the government support this. This is still state money, the public money. I look what's going on in states. You know, the DARPA, for example. They pay for the first folks of planes, of whatever they are doing, yes? We should have the same situation in Europe, and we have this. There is no problem to support renewable in billions of euros. There is not problem to support the hydrogen, sorry, in billions of euros. Sorry. And we should have the same tool for nuclear. In this moment, we can start. You know, in discussion of Euratom, it was proposal that maybe we should suggest the European Commission that they will be support the folks or the technology demonstrator. Come on, it's not possible. It's not possible. Please ask your governments, ask the European Commission why it's not possible to invest, like in the United States, the public money on the European level, not only on the state level, in the folks, in the technology demonstrator. Because industry is very interesting. I have a very often situation that I try to sell my, HTGR. They say, okay, where you have this HTGR? Oh, sorry, maybe in some years. Okay, then come later. This is the problem. In China, they solved the problem quite simple. We are talking here about the first HTGR somewhere in 10 years. In Chinese, since 2 years, they have two. Last year, they make a decision for HTGRs purely for steam generation for industry, petrochemical industry. 6 pieces. Yes? That is some estimation that in 2030, when we maybe think about the commercial version, they probably have something like 20 HDR PM reactors. This is serious. Sorry, that is unfortunately not very optimistic. Thank you.
I have a last question related to financing, and I would like to ask it to Nicola Rega. You have heard about the different initiatives at the European but also at national level. You know, both have advantages and shortcomings. Now, you are representing a European association with different types of industries in different types of countries. What do you think would be likely the more successful approach? Would it be a national approach, where you have to deal with fewer people, with fewer players, stakeholders, etc., or would it be a pan-European approach? What do you think? Do you have an impression on that?
Yeah, thanks. For a moment, I thought you wanted to ask me if we were ready to finance the project. Like, I'm not sure end users have that type of pockets to support. No, I think this is where really we need to show a bit of who we are, because we are, and as Joseph was mentioning, we are in this very tough competition on all sorts of levels. And we all know that if we pull resources together, we can advance much faster than if everybody does his own little thing in his own little corner. So from a rational point of view, clearly, if you can go ahead with pull resources together when there is most added value and we can advance much farther, that's where every textbook will say that's the way forward. The question is really whether there is the political willingness from governments to do so, or whether every single government in the EU needs to develop its own small project on SMR. That is, to me, is the best recipe for disasters, because then, as you were saying, like we see other competing economy going massively straightforward, fast, and we do this kind of nanism approach. So my suggestion would be always to let's try to pull resources together. What I feel is missing still is this sense of urgency. There is a urgency from the demand side. There's also urgency from the supply side in terms of competition from other areas of the world. So this is where probably in the narrative that should come up a bit more strong. Like we are in a tough situation. No matter how we look at it, we need to act together at the European level. To me, that is the best way forward. If there is that cannot work out, then at least let's try to be smart and try to do some sort of joint projects where we try to pull together at least 2 or 3 countries where something is moving, try to help them move forward together.
So thank you. That's really, I think, a very visionary approach, and I would subscribe to much of it. Thank you so much. You give me also a keyword for a little transition from finances to another aspect of resources, and it is human resources. You have heard a lot already at this conference about skills, about labor, about young generation, about involvement of more women, for example, in STEM activities. What is your analysis in your different organizations? Do you have enough younger people already? And actually, can you, if they are available, I mean, Italy produces more nuclear engineers than their industry can absorb. So this is a very successful export product, I must say. So that's true. But well, do you think are there enough posts available to actually absorb all these people? Because I've spoken with a number of young people here. They are actively looking for challenging posts, challenging development opportunities, career paths, and so on. But are there actually, can we offer them opportunities, concrete opportunities, a contract? I mean, I've seen here there's what's it called, a headhunter running around. Now, is our established industry and end-user industry, nuclear industry, research organizations, are we prepared to welcome these people more easily than this was the case in a few years back? Any opinion on that?
If you want, since you mentioned Italy, I will start. So Italy has a long history in producing nuclear engineers, and because of what I just mentioned, most of them were moving to abroad to other challenges because Italy was not able to retain all these talents or all these brains. Things are changing and we are actually lacking expertise in the nuclear field. However, I would like also to point out that the nuclear industry is not made only by nuclear engineers. It's made of by any kind of engineer, civil, electrical, structural, mechanical, which, however, needs to have a strong nuclear awareness of what is needed by the nuclear industry in terms of quality, safety, in terms of potential risks that are specific of the nuclear industry and other industries do not have, radiation protection, shielding, so on and so forth. So what we are doing, for example, in Ansaldo Nucleare is launching a master, high degree level education at corporate level, where we are basically hiring 20 talents from any engineering, physics, chemical degree, and we are providing them this nuclear awareness to work in the nuclear industry. And I think that at European level, we should think about initiatives with NN. We are doing it with the Young Nuclear Association. We should do it in order to speed up this process, because new generations are looking at nuclear as an opportunity today. We will start studying, and they will come out of university in 5-6 years. If they have a PhD degree in 8 years, we cannot wait for that.
Thank you. Stefan, you wanted to intervene?
Yes, perhaps to give a few figures from France, which is a bit different, because we have actually quite large industrial and energy industries. In France, it's 220,000 people working in the nuclear industry, and the figures given by the government and people working there with the projection is 100,000 new people within 10 years. It gives you the ratio, which is quite impossible, 10,000 per year. You have to take into account that in France, we graduate each year 40,000 engineers in all fields. It would mean that we would take 25% of all the engineers in this field. So it's impossible. So of course, we think that we have to think about a national and a European vision of that. And I'm also pretty convinced that to answer all the questions we had, we will not have national supply chain. We will need European supply chain. And because CEA is a research organization with Louise Gut, the scientific director of energy, which is there, we only are able to support 130 new PhD every year in this field. And we are thinking about the possible career. And you know, in France, the problem is you enter industry, you enter in academics, and that's it. And I think what should be interesting is to find a new way and new careers where, like in Germany, for instance, it's possible to jump either on academic, on industry, because there is connection, because there is new topics. So we're trying to find also new way to provide career for young generation.
So, yeah, thank you. France is an established nuclear country. Now, the opposite is a new nuclear newcomer country, that would be Poland here, for example. Josef, do you have the measures in place to attract and keep young people in the business?
Okay, that is so that in nuclear power plant you need maybe 20% of the people with the real nuclear background. The 80% you can prepare in 1-2 years, yes? That it's not a very critical number, generally. But the problem is, can we guarantee these people the interesting job over the next 20 years? Can we have so much working places for them? This is the problem. This is the problem. Of course, we are now developing. We are now in Poland as a newcomer country, as Michael told. Yeah, we need. There is the problem also because there is the coming company and try to find the people on the market. This is not very deep. There is not so much people, you know, available. There is a problem. But I don't think that taking into account that we have still a lot of time before this power plant started, that we can cover these needs. Yes, that universities, technical university can cover these needs. But the problem is, and this is important, yes, how many people, how many positions related to the nuclear industry, nuclear generation, we can give these people for the future. With okay, when we build a power plant that will be working in 100 years, there is not a problem, yes? Few generations will be necessary, but there is not so much people. There is a question that is still not solved, is even as I see in Poland is the situation, okay, we build now, boom, a lot of people starting to, a lot of department, division of the nuclear energy in universities is open and so on. But what after? What after these 4 or 5 years? And this is something what we should guarantee the people. That means guarantee not only in the Poland, but also looking on the other countries in Europe. That means we need this real renaissance and we need to develop the nuclear in Europe. Then we have the opportunity for these people. Otherwise, Saudi Arabia or something like this. Thank you.
Okay, thank you very much. So I think there's still a lot to do on the human resources front and a lot to do to convince our young generation to actually join the nuclear sector or the end user sector, chemical industry, for example, steel industry as well. There are plenty of opportunities indeed, but I think this has to be better known and well, the puzzle has to be put together. I wanted to ask you another question. We have heard in many of your presentations that you're already like fixed on a single application on a specific reactor. Now, I would like to know from maybe Paul first, what is your approach? How did you come up with the HTGR as a solution for the UK? Can you explain a little bit the path, how you came up to that sort of selection? And what would you recommend to others to do to find their favorite SMR type?
Well, have your own favorite. That's people's choice. But the UK context, I think I set out a little bit in my presentation. But if you go back a few years, the UK government were looking at, and there was a lot of technologies. So, you know, in recognition that you can't support everything and you need to kind of focus down. Because again, when we're talking about financing or people, there's only so many projects that you can support. So, but in the UK context, I hope people are aware we operate advanced gas reactors in the UK, gas-cooled reactors for many years, graphite moderated. So experience of gas-cooled reactors and high temperature reactors is already there. We hosted the OECD Dragon project a few decades back now in terms of demonstration of high temperature gas reactor. And the question for government was in terms of producing high temperature heat and deploy at scale by 2050 without the need to look at fuel cycle, what reactor technology would be most suited for the UK. And that down-selected of the advanced. They asked the Nuclear Innovation Research Office. It's published on the government website, multi-criteria analysis, that selected high-temperature gas reactor as the generation 4 technology of choice that's right for the UK. But I must keep reiterating right for the UK or to deliver by 2050 at scale. You know, if your goals are different, you can choose differently, but that allowed to focus down. That then the next stage was to go, okay, we will support demonstration of that technology, which became the Advanced Modular Reactor Research Development Demonstration. They asked for calls for technologies to be demonstrated of high temperature gas reactor. So I think, you know, in terms of that, we still have challenges around that. I think we've not mentioned here, but again, the maturity of fuel supply, I think, is one of the other key aspects. We will have the ability to fuel a high-temperature gas reactor in the next couple of years in the UK because of the parallel investment in fuel capability. I think that's something, for context of particularly the advanced systems, have people considered the fuel cycle. We've seen delays both in the US context and the Chinese context because of fuel supply and front-end fuel cycle. So I guess we don't want to go into that here, but it's a context of the UK considered. Can we fuel and is it the right technology for the UK?
Thank you. You give me a keyword to swap to Stéphane. In France, the situation is a little bit different than in the UK. You spoke in your previous speeches quite a bit about inclusion of fuel cycle, for example, fuel cycle aspects, but maybe even in a broader sense, the ecosystem of a reactor or the energy system on the whole. How would you formulate like the boundary conditions for integration of nuclear in future energy systems? And is that an argument for France?
In fact, what mentioned previously by Paul and by you, Michael, is and when you're talking about more than electricity, new markets and new application, you quite rapidly consider that it's not only a concept of reactor. It's obviously reactors and the fuel cycle. And the fuel cycle is often connected to national regulation. For instance, in France, our vision is a closed cycle, therefore reprocessing and recycling. And therefore, it means that what we have to deploy in terms of new concept, new system, has to take into account that one day you will have to manage the spent fuel and in terms of reprocessing and in terms of final depository. Therefore, till the beginning, you have to take that into account, and it gives you an idea of what are the level of maturity, not only in terms of design of reactor, but in terms of spent fuel management. And it's different in every country. That's the reason why it's interesting to share and to see that. I don't say that France has the good answer. It's our answer. And it's interesting to share with other countries and to other policy to see what should be the interest. And connected to that, and my final advice should be in terms of licensing, because we are speaking about European application. Of course, if we can start till the beginning, not only with one domestic nuclear safety authority, but several safety authorities. We started to do that with NEWARD in Europe, for instance. We have other applications of that. That's very interesting, because working with different national safety authority, they have to take into account to face those questions about the concept and about the final management of the waste. And then you can gain a lot of time if you have several countries working together in terms of final deployment.
Yes, thank you. You have given us a lot of food for thought. I mean, talking about food, it's about almost about lunchtime. We have to do two things still. One is I would like to take one question from the audience here, and then Stéphanie Cornet wanted to give a little summary from the session, if you want to. Yeah. If you have time. Okay, first, could you please say your name, your affiliation, and to whom you are asking the question, please?
Hi, I'm Janice. I'm a master's student in the Polytechnic University of Catalonia, and I wanted to ask about the possibility of generating hydrogen based on an in situ reactor that's producing hydrogen. Is there any project working on that?
The question is coupling nuclear plant to produce hydrogen.
To produce ammonia.
Ammonia. Directly ammonia.
No, through hydrogen generation.
Okay.
I can maybe answer a little. Yeah, there is a very interesting project related to production of hydrogen. Not in Europe, but in Japan, we have a HTTR, and we have they build directly some factory for production of hydrogen with the only heat using. This is the
steam methane reformation.
no, this is iodide and
iodine sulfur.
Oh yes, sulfur. Sorry, sulfur iodide system, and this is only with heat. and this is ready installation. They now, probably next year, will be connecting the HTTR with this factor and try to make this real. In Poland, we have also one project that is related to production of hydrogen with high temperature. It's mostly thinking about splitting, thermosplitting, not, of course, electrolysis, but we say the starter, this is a pure research project now to find the right way how we can do this. But I didn't heard about the other project, sorry.
To answer your question also, that at this moment, 3 European projects closing. They have been running for 3 years, Gemini 4, Tandem, and NP HYCO, which is short for nuclear production of hydrogen cogeneration. So these 2 projects, I think there are also posters here. You can look them up, and then maybe you can come and we can have a short discussion on the subject.
Yeah, if I may, I don't really know if you have a specific cycle in mind, but there are multiple technologies to produce hydrogen at a very different level of maturity. In Europe, we've been focusing a little bit more on high-temperature electrolyzers lately, which is not a fully mature technology, but still at a pilot level. However, there are other options like sulfur iodine, which requires quite a high temperature input. There are also lower temperature processes. We are now assessing a copper chlorine process. There are processes that need both an electrical and thermal energy input, like the high temperature electrolyzers. Others that are purely thermal, maybe with catalyzers or a specific chemical reaction. So there is quite a huge landscape in terms of hydrogen production and coupling with nuclear power plants. We haven't investigated all the technologies so far, but...
Very quickly, for 5 years, I was the chairman of the hydrogen production project arrangement within GIF. And therefore, what was mentioned, you can find all the data through the GIF website, and you will see all the possible way to produce hydrogen. And if you have hydrogen, therefore, you can achieve to LOHC, liquid organic hydrogen carrier, and ammonia is, for me, the first one, the most simple. But you can see that there is a lot of countries, 8 countries within GIF are working in this field, so with advantages and drawbacks, and that's very interesting to share that.
Can I just do a bit of an advert? There'll be a joint report from GIF and OECD NEA on high-temperature steam electrolysis from high-temperature gas reactors in the coming months, so that'll be a summary to have a look at in terms of...
Yeah, thank you for this. One last question from the audience, if you want to.
Roberto Dinolfi from Ansaldo. Let's take the opportunity to have Mr. Rega with us, because it is an opportunity, certainly. We have been talking a lot of de-risking and so on, in order to... And then the question is very simple. From the point of view of new customers, like you are, which are the 2 risks, or 1 risk, that you will never accept from nuclear supplies? The difference that I see is that our industry is structured sharing risks for electricity producers, big ones, that can accept fuel management, can accept liabilities and so on. Are there clear ideas on your side which are the risks that we should reconsider and reallocate from your point of view?
I think, our industry is quite used to deal with very different risks when it comes to managing our assets. So that, what I would say, that 2 main areas. One is, the liability element in there, because most likely we are dealing with assets that we will not know how to manage. So it will be in the hands of someone else, which is the opportunity for the energy industry, but it's also a big risk from our side, because whenever you talk with our energy managers in our industry, but that applies also to other industries, they want to have full control on the output of those installations because they need to match the demand for the products, for the production side. So there is a clear control element there, and we need to know what happens when, like, can that be always accommodated, yes or no? What are the elements in there? What are the risks? And of course, in case of malfunctioning, what are the liability consequences of that? I think for the rest, as long as it provides low OPEX, we can sort it out.
Thank you. Maybe you can continue the discussion over lunch. Last step, today we have the honor here of having our rapporteur, Stephanie from CEA. She will say a few words in summary and then...
Yes, thank you, Michael. So I'm going to try to summarize the discussion in 2 minutes. So it's a short summary, as we say in French. So first of all, I would like to thank the moderator and all the speakers. I think it was a very interesting conversation. I really enjoyed the fact that you all come from different countries and from different backgrounds as well. We have people from research organizations, industrials, and so what I've noticed from all the presentation is also we talked about different technology for non-nuclear, non-electric application. We all seem to look in the same directions, so we look at the same applications. I liked also the comments that was mentioned a few times, so we came to the same conclusion as well, which is like when are we going to deploy those reactors and how much it will cost? And what do we need to prioritize as well? So, and how do we secure investment, especially within the European Union? We also talked about we need support from the policymakers, and there's still a lot of challenge to be overcome before we can deploy such reactors. And you also all talked about the different EU projects where most countries are involved, like Tandem and Gemini, etc. So the second point I've noted is the target market. So they all agreed that the first target market should be district heating, or might be district heating, because it already exists, so it's not new. In terms of financing, so we need a mix between public and private fundings. And we also need to look at the balance of risk and the role of government in financing. And we also need to pool resources together. And as a famous sentence that Stefan used to say, it's true that together we go further and faster. There's also the sense of urgency that is missing. And the fourth point we've mentioned is all the human resources and capacity building. So we need to find new paths for to allow people for career change. We also need to make sure that the job that we offer to the young generation can be guaranteed for a few years, well, at least 20 years. And we also all agreed, I think, that we need to work on capacity building and human resources as a whole European community, and not only look in our own countries. I think that's it for me. I don't know if you want to add anything else that I wouldn't have noted.
Thank you very much, Stephanie. Once again, thank you to everyone that attended, especially the young generation. I can see a lot of us are here. And thank you very much to our esteemed panelists. It was very interesting deliberations. And I hope that everyone took something home and something to think about, food for thought, as we're going to have it. So thank you, everyone. Thank you, Michael. Thank you to me.
Yeah, so thank you also, Alexis, and for all your availabilities, of course, and preparation work that you have invested. Thanks to the audience, and I don't want to forget all the people here backstage for your support. Thank you so much, and I adjourn this meeting.
can. That you have. Just with me when I. Yes. No, So probably we can start. Good afternoon, everyone. Welcome to this fantastic session that is going to talk about very good stuff, basically only success stories in collaborative work. It's not going to be that much scientific, I believe, or I hope. It's going to be about what we have been doing good to be all together here. It is the success that we are all here together, right? And we are going to tell you a little bit the experience of each one of us, how this happened, that we are working together independent of the place we are coming from and all this stuff. So I am Abdou Al-Mazouzi, by the way, for those who do not know me, from EDF and SNETP. I will be co-moderating this session with my young colleague, Oli, from VTT, right?
Hi, everyone. Yes, Olli Soppela from VTT. Nice to see you all here.
Excellent. And we have fantastic guests here, fantastic speakers. They will introduce themselves slowly but surely. And they will start with my very old friend. Old friend, Marta. She's young, but she's my old friend.
So, hello, everyone. My name is Marta Serrano. I come from CIEMAT, Madrid, Spain. I am a mechanical engineer, and I want to highlight that I did my master thesis in 1991 on the old-fashioned Plimplex methodology. I am not sure that someone in the audience remember what means Plimplex. It's Plan Life Extension and Plan Life Management. So I spent 3 years working on this issue in a nuclear engineering company. And I work in this project for Garoña and Vandellós one in Madrid. Then I did an MBA. It's a parenthesis on my life. And then I joined CIEMAT in 1995. And since 1995, I am working in the same place. I only moved from my office once in 30 years. And now I am the head of the Material for Energy Interest Division. That means that we not only work on nuclear materials, we work on material under extreme environments and so on. I have experience in European projects since FP4, and I lastly coordinate the Entente project on database management and so on. And that's all, I think.
Excellent, thank you very much. So, huge experience, but still a lot of experience to come, right?
Of course.
Thanks God. Then we have with us Petri.
Hello, good afternoon. Petri Kinnunen from VTT, Technical Research Center of Finland. And I work at VTT in the role of research manager and quality manager in nuclear energy. I'm graduated from Helsinki University of Technology as Master of Science in 1998 and then Doctor of Science in Technology in 2002. I give you a secret now. I have never studied nuclear technology, not a single day. And I ended up to this route by accident. I was supposed to do totally different industry, but then one side step led to another, and now I'm in a situation that I've been working here almost 30 years. So from my point of view, I have made my career from the basic research scientist up to the research manager. I have seen the whole chain, what people can do. And as a Finn, I'm proud to be here because I have been hearing Posiva CEO giving a talk. I have seen other Finns to talk. There are plenty of success stories happening in Finland, have happened already and are still to come. And I'm really proud to be representing my country and our organization here. My scientific background is I'm an electrochemist, and I have done my studies in investigating corrosion and oxidation problems, which are of course important for nuclear power plants as well. Of my 27 years in the field, of that time period I have been working with Joule Horowitz reactor 18 years. First as a responsible manager of our national in-kind contribution to the JHR, and then the last 8 years also as a governing board chairman of the whole consortium. That has been a really interesting project, and I hope it will become a big success eventually. We can talk about that project later, if it's success story or unsuccess story, but there are both in that. But it has been the industrial nuclear high school for myself to learn how this kind of nuclear reactors are constructed from the scratch. So I think that's all from me.
Thanks a lot, Petri. So we move to Maria.
Hello, good afternoon. My name is Maria Śmietanka, and I will go even a step further than my co-panelists. So I have no background in nuclear research, and I am not working in nuclear research. So I will be only pretending that I understand what my co-panelists are talking about. I'm representing here National Center for Research and Development, which is the largest funding agency in this part of Europe. And more precisely, I am a deputy director of National Contact Point for Horizon Europe and Euratom program. So I'm dealing with helping Polish participants to get grants, to get funding for their bright ideas, brilliant ideas. And that is why I have contacts with so many scientists and so many good ideas. And if you are interested in getting funding for your ideas and you are looking for Horizon Europe funding, then we will be more than happy to talk with you and to provide you guidings on how to get grants. So we can stay in touch, and if you are interested either applying yourself or finding Polish partners to apply with you for grants, then we will be ready to help you.
Excellent. I think that many people, they will get your address, don't worry.
Hopefully.
Thanks a lot.
That is why we exist.
Thank you, Maria. Alphonse is also with us today. Please.
Before I come to my personal expertise, my name is Alphonse Weisenberger. I'm from KIT. So KIT is the only research university we have in Germany. We are relatively new. So we are founded I think in 2021. Basically the final founding of the KIT takes place, and we are basically combined from the oldest technical university in Germany, which is the University of Karlsruhe, founded in 1825. So we have 200 years of celebration this year, which is celebrated the entire year in Karlsruhe, by the way, and with the research center, which was founded in 1956. And the research center, probably if you're aware with founding research center at that time, was basically to deploy nuclear reactors in Germany. And so we are the merging of that at the KIT. We are still active in nuclear business in USAFE, where we have basically two topics: nuclear waste disposal and safety assessment of nuclear systems. And in this safety assessment, we also deal with material development for new and advanced reactors. And nowadays, we are officially allowed also to take the word reactor in our basically mouth when we talk with our bosses and around. It was not the case, let's say, 10 years ago, where we had to hide behind the safety research, but nowadays we still can basically do material research officially at KIT. And as you probably know, KIT, basically Germany, will not, I think, in the next years design and build a nuclear reactor, at least to my understanding. So we offer our expertise normally to European projects, to European alliances, and we have streamlined our national basically project along these lines. So that's basically our mission, what we have in that. For myself, I'm by education mechanical engineer, and I think that's written down that I am nuclear engineer. I think it was one of the last nuclear engineers of the Karlsruhe Technical Universities at that time. But then I shifted 1999 with my PhD to materials, basically nanostructural materials, which is totally different. And about 2 years later, I come back to nuclear, basically when we started the lab activities at Karlsruhe, thinking about materials that can withstand extreme conditions, like in a lead-cooled fast reactor. And since that, we are dealing with that, not only in nuclear, like CMAT, also for basically other renewable techniques and things like that. And my expertise is basically really compatibility, improvement of compatibility, new materials for these development. And I bring these expertise also into the OECD expert groups, which are dealing with advanced materials and the components for liquid metal cooled systems, and also in the IAA activities.
Excellent. Thank you very much. Well, we are very proud to have the last German nuclear engineer then. Hopefully you will make some kids after you. They stay with us because we like you. No problem. So, and then we move to the real nuclear stuff. Eloise, please.
Hello, good afternoon. It's working? Good afternoon, everybody. I'm Eloise Gut. I'm a scientific director of energy at CEA, and my background is nuclear physicist. I got a PhD and an habilitation in nuclear physics. So my first expertise is theoretical description, microscopic description of nuclei, fission process, etc. And then during my career, I got different positions and in nuclear physics, but in a large sense. And for instance, nuclear physics for nucleosynthesis, or I was also appointed deputy director of GANIL, which is a large-scale infrastructure in Caen for experiments with radioactive beams. And then we are doing experiments for nuclear physics, but also biology or atomic physics. So, and now I moved from a little bit from fundamental research to more applied research, because now I'm in the division for the energy in the CEA, and I'm working as scientific director. If I have only 2 minutes, so I would like to present very rapidly CEA. CEA is a French public research and technology organization. So we have 4 different areas of work, so defense and global security. We have health, new technology for digital transition, and of course, the energy transition. And concerning the energy, so we are promoting innovation, both regarding the technologies used in the nuclear field, but also in the innovation in the use of nuclear energy to fully decarbonize the society. That has been already presented before, but I would like to highlight that. And to finish, just 4 key points that I would like to emphasize is what is important for me is really the approach we are developing from materials to use case. Second point is from lab to fab, so the link between R&D and application. Third point, I think that cross-research activities are drivers of acceleration and innovation. So, and for instance, we can talk about nuclear and non-nuclear couplings and joint project. And that last point, I think that it's also important to have a global view between experiment, databases, and simulation. Thank you.
Excellent. Thank you very much. It gives us a little bit the vision where we are going this afternoon, right? To see how we can build the success together. And we have also Mariano with us. Welcome.
Thank you, Abdou. Thank you, everyone, for inviting me. It's a real pleasure to participate to this panel. I am Mariano Tarantino. I work at ENEA. ENEA is a public agency in Italy working on nuclear stuff. Then I will spend a few words about ENEA. I am graduated in nuclear engineer, one of the few that still live in Italy, so please protect also me. And but I got my PhD on, let's say, on innovative nuclear reactors. And my career was very simple. When I started to work on liquid metal, and I'm still working on liquid metal. So I started in 2003, and so it's more than 20 years working on liquid metal technology. And today I have the pleasure to be the responsible of nuclear energy system division in ENEA that belongs to the nuclear department. And my team work mostly on fission reactors. So we develop technologies for fission nuclear reactor, both for SMR. We are working on SMR. So this is really, let's say, a topic for the discussion, but also on lead-cooled fast reactor. This is more or less the topic in which we are working. And now we started also to work on a space application, a reactor for space application, quite new, really fun, and we are spending resources to work on it, but it's really interesting. A few words about my agency. As I told you, we have the so-called nuclear department in Italy that is consists of about 450 people, so not so much, but most of them, more than 50% are working on fusion. The rest is working on SMR and LFR, including also waste management and some few support for decommissioning. So we are quite a small, let's say, team. If we are looking forward to restart with the nuclear, you know, now in Italy, we are discussing this topic. We got also the so-called national platform for sustainable nuclear launched by our minister. We supported the roadmap for the relaunching the nuclear in Italy. And one of the main concerns that we have is who will do all this work. So there is a lot of work to do. And hopefully a panel like this will help us also to introduce what we are doing, to involve younger generation, and to promote European collaboration. I will close telling you that I started with my first European project in 2003, and since 2003 I never stopped to work in the frame of European projects. So this is really, let's say, a pleasure to tell you that this was really an opportunity for us to keep alive the competencies, the capabilities, and to promote in the technology development. So I guess we'll have time for discussing a little bit. So thank you, everyone.
Thank you very much for being with us. Uli, can you start with the first question then?
Happy to do so. But first of all, I would like to propose a round of applause for our distinguished panelists. So we start with the individual questions, and this first one is directed to Mr. Mariano Tarantino. You mentioned the innovative reactor development work you have been involved, and ENEA has been deeply involved in lead-cooled reactor testing and qualification. Could you highlight some of the most impactful projects that you have worked on in this domain?
Yeah, as I told you, when I started to work on this, the project was EP Eurotrans, so it's 2003, 2004. And since that time, we continuously worked to develop technology on LFR. So project by project, we have achieved important outcomes. We have developed the technology. It's worth to mention that along this roadmap, we have, for example, developed the technology that at that time was impossible for us to manage. I remember when I was a student in ENEA, the so famous oxygen sensors coming from Russia. No? They were very costly, very fragile. We started working on this, and now if you have a look, thanks to the European framework, we have developed by ourselves oxygen sensors. So in Enea, we are able to do this, but also in Germany, in Belgium, in Spain. So the community is able to manage this technology that at the beginning of the time was, let's say, something very far in Russia we cannot achieve. And this is just a successful example. But thanks to many projects, I do remember, for example, LC project, LEADER project, when we started to design the system. So there was also this, let's say, sort of dream to develop new system and to design new system. We have discovered several things. I joke with my students. I ask them to go on Amazon and to Google and to find a pump for liquid metal. You cannot find it on Amazon, okay? But we have developed it. So this is thanks to the framework that we have created in Europe, in which we not only develop, let's say, let me say in bracket, papers, but also technology that you can touch. Pump, steam generator, DHR. But then we have developed also numerical tools. This is very important. Europe invested a lot on the numerical tools, and nowadays we are able to make several simulations with great accuracy and also great capability. And now, on some of these topics, we are a reference worldwide on this. So there is a long list of successful history in Europe, thanks to the European project. And I guess we are continuing in this direction. Now, new projects are coming. I just want to mention Connect and M. It's the right way, according to me, to put together all the competencies, the capabilities in the frame of nuclear materials. So this will be very important to proceed to go ahead.
Excellent. Thank you for the answer. And I think your great work has inspired many new projects around Europe afterwards. Yes. And also new applications for the mentioned technologies developed. The next question would go to Eloise. You have significant experience in fundamental physics and accelerator projects. How do these research areas contribute to the future development of nuclear energy?
Thank you very much. First of all, what are for me the objectives of R&D in nuclear energy? I think there are different kinds of situations. The first one is that we need to have very reliable data, tools, and very precise tools and data for explaining the current functioning and explaining what is not so far from this situation. But we also need to make predictions to conditions that are completely different. We can talk about long-term operation, we can talk about long-term storage or severe accident. And we need also to make innovation to new topics. So things that have not been developed, new reprocessing process, new concepts, etc. And I think that it is important that for that, fundamental research, in fact, it's based on the knowledge of fundamental phenomena, physical, chemical phenomena. And then they can establish a really solid and credible scientific basis. And I really think that they are important in that sense. And that's why fundamental research is helping to develop new knowledge in the different components in nuclear physics, thermohydraulics, in all these components. But it's also helping developing experimental devices, sensors, or detectors, etc. But also methodologies and or also everything we are discussing about AI. And just to finish about my personal experience, I can mention what we have done theoretically and in Ganil. So we were working on completely fundamental experiments related, for instance, to what we call exotic nuclei, so very heavy nuclei or very neutron-rich nuclei. But all these experience of nuclei that exist perhaps in the stars, but that are not now on Earth, these very radioactive and short lifetime nuclei, all what we learn help us to better understand the nuclear-nuclear interaction and also help us to have more precise nuclear data that are useful. So that means that the fundamental phenomena and the fundamental bases are the same. Whatever the application is, we can do medical application, we can do energy application, we can do nucleosynthesis, whatever, but the fundamental phenomena are the same, and they can really provide a scientific, credible basis and improvement for accuracy.
Thank you, and I think we all owe you a big favor of researching the actual building blocks that all the rest of us build our research on. So thank you for that. The next question is going to Alphonse, and you in KIT have been involved in multiple research projects, particularly regarding the corrosion in fuel elements. Could you share with us some of the key learnings from these projects, please?
So one of the key learnings that it takes quite a long time to develop material that can be used, because we did that now. He mentioned it. I think I was also in this EURADWASTE project. We started there at that time. I think it was also cladding materials and pump materials. But if you ask me now, which is the real material to really build a, let's say, a lead-cooled reactor that is operated at, let's say, the temperature we would like to have, like 600 degrees C, I say, okay, it might be an alpha steel, but can you buy it somewhere? No. So 20 years of research, we know definitely more than we knew at that time. But what is interesting is that basically from the beginning, we at KIT already basically promoted the idea to have an alumina scale that grows in situ to protect the material, basically adapting that from the gas turbine field into the nuclear field. And this is basically still the approach. It goes different ways, because first of all, everyone studied the ferritic martensitic steels, much better irradiation resistance than the austenitic ones. Unfortunately, some guys came around, I think it was at SCKCN, and said, okay, there's liquid metal embrittlement, so you should not consider these materials for fuel claddings and other things. So then basically we looked into and then we ended up with austenitic steels, and of course trying to have short-term solutions with surface modification, things like that. But at the end, of course, if you have really a material that can grow itself, the protecting scales in situ, this would be the ideal situation. So I think that's one of the things that the idea basically how to do it was there from the beginning. But it really took several steps around, basically then to come to the point where we are now and say, okay, we have really to focus on these development of these new kinds of materials. And I think even in the last years, what's even more important to consider also basically what Lorenzo mentioned, this paradigm shift. So not trying out and looking what happens, really to think, design the material, and also design the test basically, because that's also important, that we are able really to do the right testing, the right qualification that can save us at the end time to come to a standardized material. I think from a scientific point of view, at least if you asked me 10 years ago, is it important to think about standardization? I would say, no, I don't like that. But nowadays it's clear, if you want to build something, and I think we are now at the stage where we have to start building, otherwise we will never build anything, you have to think about that standardization. You have to get the material over the next basically level, this valley of death in TRL. And if we don't do that, and if we don't think that from the beginning, I think we will never have the chance to do that. But I'm quite optimistic that the new approaches and what we do in Connect&M, we will come quickly forward.
Excellent. Thank you.
Thank you very much for the answer, and really going hands-on from the drawing board to the practical qualification. I think that's a very demanding and brave path to walk, and we are happy to have you doing it. From Maria, I would want to ask the following. As a European project coordinator, you have a very good overview, maybe also a little bit like bird-eye view from outside the industry, as you mentioned, of many initiatives. What do you think are some of the most successful collaborations that you have been part of?
Oh, thank you. Oh, sorry. I hate using microphone as my hands are shaking. I hope it is not as annoying for you as it is for me. I'm trying to do something with it, but yeah. We are, like as national contact point, we are seeing a lot of projects and a lot of interesting projects, and being a bit outside of those projects, looking like maybe like from the eagle's eye on all the projects. So, but I wouldn't dare to say that one of them is better collaboration or more successful than the other, because always when I see a project, I see enormous amount of work behind every project. And whether it is like more research project conducted in a lab or something more closer to the market or something more soft connected with exchange of knowledge or policy building, there are always engaged and creative people behind it. And it's like my co-panelists, when they are talking about what they are doing on their field of interest in their research work, you can hear that they are fascinated with it. And we are also, and at least I'm starting to be also fascinated with this area when I hear about it. And meeting those type of people is, I think, the best part of my job. So I wouldn't say that there are more successful or less successful cooperations. And I was studying interdisciplinary studies, and it was when I had lectures in law faculty or in physics faculty, it was like touching two different worlds. And actually, the lecturers even have spoken like different languages, and the way they have seen the world was totally different. And when you are building a project, you also need to combine different words, because you have you usually have research organizations, universities, companies, maybe some NGO, maybe some public administration, and they have so different views on the things you should do, on the way how you should do these things, on what is most important and what is less important and what they want to achieve, that really I'm really surprised that in the end you manage to do something. It works, yeah? It works really good. And I was always worrying that in Poland we have problems with intersectoral cooperation. And like a few years ago, I have taken part in a conference at Oxford University, and we have spoken about cooperation between academia and entrepreneurs. And Oxford University said that, oh, it's so difficult to cooperate with entrepreneurs. And this is something, I mean, like a never-ending story. You need always to take care about it and try to do it, although it is very difficult. And then I felt relieved. I mean, if Oxford University has those type of problems, then, I mean, we all have. And this is really something, I mean, you will not overcome like easily. So you need to work on it. But projects is something which gives you the opportunity to meet new people, to meet their different point of view. And so from this point of view, I think every project is successful, and because it gives us a new knowledge and it gives us some different point of view which we can take from it and use it later in our life.
Thank you very much for the...
Thank you. And I think very well highlighted that the journey together is at least as important as the destination. So
it is, I think.
Okay, and the next question would go to Petri. As a research and quality manager at VTT, you oversee a large portfolio of different kind of projects and research infrastructure. Could you give us an overview of the main projects currently underway?
Okay, I was thinking from which point of view I should approach this question, and should it be VTT, should it be Finland's, or should it be European point of view? But it doesn't actually matter because they are all the same eventually. So first of all, I need to mention that European Union is the biggest nuclear research funder at VTT. So we are very active in many European Union projects, Euratom projects and also other projects. But from the research infra point of view, I already mentioned the Sjuhäravis reactor. It is by far the biggest effort at the moment. We have our national infra constructed some years ago, so it has been also effort for us. but from the European level, JHR is a big effort, and then of course now there starts to be these plans for building SMR demos, etc. So these are the infrastructure side. Then from the traditional research side, of course, many times mentioned partnerships, EURAD2 and Connect NM. VTT has been very, very active in both of those. I have been personally involved in establishment of this Connect NM. And there are colleagues here in the room who have been very active in EURAD. And they are important in the sense that they really stretch our capability of do cooperation in the European scale. Both of them have tens of partners. Connect NM will end up having something like 50, 60 partners. EURAD2, more than 100 partners, close to possibly 150 partners. So they are huge efforts from everybody. Then from the other projects that are now ongoing, there are of course Easy SMR project, which is sort of like a partnership, but not exactly a partnership. 50 million euro project from the European Union point of view. And also very important for many countries, like Finland, who is now, we are now designing our own LDR-50 reactor, which is meant for the district heating and going to be an SMR. So important effort for us as well. Of course, conventional long-term operation projects, there are a few of those. There are severe accident projects, there are digital twin project called Dorado. And there are plenty of these kind of projects that seem to now be forgotten to a certain extent now when everybody talks about SMRs and partnerships. But they are still there and they will still remain there, and they are very important also in the future. But I think that the partnerships are now ruling out at the moment together with the SMR projects, the scheme.
Thank you, Petri, and very impressive portfolio, and I think a good reminder that even if we are now very excited about SMRs, that the current European fleet is actually a lot of large reactors with a lot of surveillance programs and LTOs ahead. Then a question for Marta. CMAT is actively also coordinating projects, including the aforementioned Connect NM, which deals with new materials for nuclear power plants. Could you tell us still a bit more, add on top of what Petri mentioned, about the scope and goals of this project?
So I think that Connect NM appeared in all the panels today, I think. I want to stress that Connect NM is a co-funded partnership. I stress co-funded. That means that is only funded 50%. And a partnership is not a project. And the idea of Connect NM is not new. It was built during the last 4 years in a concert action. And the idea is to coordinate all the material research activities within Euratom in one partnership. And I stress that materials mean metallic materials, fuel, and concrete. And the idea was stressed this morning by Lorenzo. We need to move from see and quantify to design and control. We need to change our mind how we are doing our research on material. But I want to add another key point. For whom? Who is interested in your results? Who is going to apply your results? Regulator, utilities, vendor, material supply people, codification. You need to be very clear who is interested on your results. The impact of your results start to be a key point. And I want to also to stress that Connect NM is based on the development of methodologies. So I will put an example. We are not going again to, forgive me, the people who are involved with that, performing ion irradiation on model alloys. We did that for Abdu. We need to change our mind. Experimentally, we are excellent in Europe, but we need to change our mind. Who is going to use your data? How you are going to store your data? And then we come here to ontology, semantics, and all of these things that are needed if we want to exploit this data with digital technologies, artificial intelligence, and so on. And I want to stress here that we need the dialogue. You talk about dialogue between different disciplines. We need to start to talk with other people outside the material business. For example, expert computer. I was coordinated the SNETP project. I personally spent, believe me, 1 year to understand what an ontology is. Even today, please don't ask me to explain what is an ontology. But I spent perhaps 10, 20 meetings with computer people, and we have different language. And then we need to sit down together and speak the similar language. It is crucial if we want to use these digital technologies and so on. And I don't know if I answered your question because I talk and I talk, but...
No, excellent. Thank you very much, Marta. So we will keep talking about this because it is the most important part. So what do you see as obstacles and what are the drivers to ease a little bit the collaboration between the end users and the developers, the research doers and the research users, and the different sectors, different the entities and all this stuff?
I think that the concert and support action tool is very useful to solve these bottlenecks before they start. And I stress to the Commission to continue to launch this funding tool because it's very useful to anticipate what problems you will have setting up this big consortium. I am married with a lawyer.
Sorry.
The most difficult and the most important bottleneck are legal issues. Legal issues is a nightmare. Believe me, between how many countries are in ConnectNM, 12 countries, different lawyers, different systems, This is, for me, the most important bottleneck that we have.
So, meaning you are meaning like, even as scientific researcher, we have to learn law or what?
No, the scientific excellence is excellent. So we only need to deal with politicians. It is not so difficult.
Yeah.
But to set up this big consortium, this big partnership, we spent 3 years. Lorenzo spent more than 3 years, 100%. Petri support Lorenzo also. I can say that a group of 4 or 5 people were working 100% for solve these problems that are not problems. There are a lot of problems of communication that can be solved. Politician, you know that each member state has to nominate someone to speak to. It was not so difficult as we expected. If you have the right contacts in the ministries, it was not difficult. And believe me, the most difficult issue is legal paperwork.
But I am going to jump to Maria because as a contact point, you should have a lot to do with this kind of thing. And how can we improve the contact points at this stage or to have success in European project or collaborative project with different mindset and different culture, if I may say like this?
So of course, we also see this type of problems, and we have in our national contact point people dealing with legal issues also, and trying to help beneficiaries to deal with it. Because I think that one of the biggest problem is that you have researchers, and it's good when researchers do the research. And you need also good managers, science managers, to deal with projects, because this is not so common situation that a very good expert is also a very good manager and can deal with different problems of the project. And you need effective administration to help you. Because sometimes we have a feeling that a good researcher wants to be a face of the project and wants to do everything. And it's really waste of resources. Because you should do this what you are good at. And if you are good at research, then you should focus on it. And you should have other people helping you with legal issues, with administrative burden and all the other stuff, which are not less important, but are difficult and time-consuming sometimes. So you just need experts in other fields also, because then there's just more time for research, for those who make research. And we are, for example, preparing so-called Academy for Managers of Horizon Europe projects, where we are teaching people on how to organize the project and how to deal with the project. Not with the research part of the project, not with the idea, because of course this is not something we can help in, because idea must be yours, but on how to do the rest, which is also pretty important and sometimes really challenging. And yeah, so I think that's the point.
Excellent, thank you very much. So Petri, how you deal with all these obstacles then in VTT, as you said you are successful in many projects. Tell us your experience then with VTT.
I was about to answer to Maria, because at VTT we have grown up a real EU department, for example. We have excellent department who takes care of all of these things. And in our case, mainly researchers are focusing on producing the scientific content for the projects. But it has taken a long time. I've been working at VTT 27 years, and I would say that during the last 10 years we have got our organization in such a shape that this works now. But it's a long learning process. But it also requires that we have recruited proper people. Lots of lawyers, lots of grant writers, and I must admit that me being a manager, I have even needed to learn some law. So I can't avoid it.
If I may interrupt, I visited VTT a few years ago and I really liked the way it is organized. I think it's a really good example of an efficient organization.
So that would be the only solution then, to have more lawyers than researchers in your company? That's what you are saying, right? So maybe Alphonse has another experience, because he's also dealing with a lot of projects. Eh?
Yes, partly. Because we also have, in some projects, in the recent years, basically, it improved quite significantly, but not because mainly lawyers basically are involved, because people with skills like managing skills, basically taking over the stuff the researchers usually are not experts in and do not like too much. And if you involve them early in the projects, it's definitely very helpful. If you have the lawyers, and it very strongly, at least at KIT, depends whom you have. So we have some lawyers that are, let's say, quite efficient and you can really talk with them, but we also have some, you have to talk to them quite a lot of time and they never will basically come to the point. So it really depends on the persons, not on the organization, I would say. Luckily at KIT we have still these kind of an over-organization on USAFE, where we have 3 people basically trying to have an overview on the different projects and are responsible let's say, in these as a kind of an intermediate contact point for also people outside of KIT, which helps definitely. And I hope that because most of these people will retire in the next years, that will not face a situation that the researchers have to do that by themselves. But this can happen. And then, of course, we would basically lose quite good situations that we have now and go into situations like other institutions have, and basically they know that it's not a good situation.
I thank you, and good luck with the new generation. All right, yeah. they are going to ask you know, the artificial intelligence to answer the questions, not anymore their brain. All right. So maybe Louise is going to teach us a little bit what are the obstacles that we have to face or how to face them, and how the Europe or collaboration in collaborative way we can overcome these obstacles in the future to do even more collaboration. Right?
Yeah, I'm going to answer. Perhaps I will first go further
okay.
about this, because this is one of the obstacles, because we are talking about that. And I think that we should not oppose lawyers, researchers, and things. We all have expertise. It's what you have. We should have, and we have, a common goal. The common goal is the success of the project. The common goal is the success of industrial deployment, R&D, whatever is the success is. That's why I liked you when you mentioned impact. We should have in mind what is the impact we want. We should measure the impact and how far we succeed. We can fail, but at least we know where we are. So that's why, for me, it's important not to have competition with the different people, and that's why how to overcome that is that at the beginning of a project is to try to federate everybody, that everybody, lawyers, non-lawyers, R&D, everybody knows what is the goal, what is the impact, so that they just not pop up at one time and saying, oh, you forgot that. No, it's not your project, it's the project of everybody. And I think that's something that is important, so not oppose that. So I think this is one obstacle, and I think we know, or at least we know how to do. So, and we are trying to do that, and I think it's a...
But usually, because we have always deadlines, and because the Commission is publishing its stuff last minute, and because this and the other, we do not have time to talk with everyone. We just want to go as fast as we can. So how to deal with that as well?
May I add? I want to share with you the CMAT experience with ConnectNM. I think that 5 years ago, Lorenzo, you know, correct me, we know that the consortium, perhaps 4 years ago, we were sitting with the general director 4 years ago at CMAT to prepare CMAT also as an organization to coordinate this partnership. Even we launched different options. Even we think to have a spin-off at CMAT, only to coordinate the project. We abandoned this idea. We work with all the directorate, and it was a very time-consuming internal work at CMAT with the lawyers, with the OTRI people, with general director, in order to prepare them that we are going to coordinate this partnership. I am sure that we will have problems. But at least we anticipate, and we involve these people, and also we convince them of the importance of this coordination.
Go ahead if you want to add something.
Yes, I agree. Your question was also about we have deadlines, and then something just comes, and then we have to answer. Yes, there are deadlines, but there are also long-term plans and long-term research, not stop and go in that sense. And especially when I'm talking about R&D, we have also, and we do that to anticipate. That's why most of the time we say that we have this short-term research, medium-term research, and preparing the future. And we also, that's why need to have these perspectives and long-term vision also.
Yeah, from my experience, I want just to stress, I fully agree with you. This is something that we can, let's say, fight if we consider this as a team, so we work together, no? And I have noticed that in the past that when we have some, let's say, critical path in front of us for a project, the solution is, it's very simple if we have a clear objective, if we have a clear roadmap, if we have a clear idea. In that case, for me, it's very simple to talk with my lawyers, we sit and we find a solution. Then when we have doubt, we copy German and we are sure. So this is what we do. But apart of the joke, when we have a clear idea, then we go ahead and it's very simple. When you have a not clear idea on what is your goal, what is your target, what is the aim of your partner, then the problem arises. Then it's not a matter of lawyer or the problem. It's a matter that you have not a clear idea where you want to go, and then people start to be conservative. No, this is the point. It's very simple. I see many times in the frame of European project, when you have a clear idea, you can find a solution without any big discussion.
Well, hopefully. So, you know, we have the small chat now, and then we are going to open now for chatting. Is any one of you want to share with us his experience or how to be successful in collaborative projects, and what are the hurdles that you see to do more collaboration? So I am also asking you to answer through the app, because it is the same question that you are asking through the application, the app. So please check it out. Either you answer directly through the app, or you answer by the microphone, and I will be pleased to give it to you. Anyone want to ask, to talk, to questions, remarks, whatsoever? We are family, eh? Just talk.
Thank you all of them. I had a question regarding, let's say, the fact that we have to add lawyers to these projects, which I totally agree. But I would like also to put in it in a different perspective, because right now, as we are also talking, we are rebuilding a supply chain. And supply chains are also based on startups, SMEs, so small companies that sometimes cannot afford to have lawyers full-time or these people full-time, and are very big expenses. And if we also, for example, compare the US to Europe on this, there's a big problem, because one of the reasons why startups and SMEs work better in the US is because at least there is a common ground of understanding what law is and all of this, let's say, where we talk about harmonization and that part. So I agree that from a legal perspective, this is important, but how can we incentivize smaller companies to actually enter in the industry, and how can you help them? Because of course, there's a difference between being a big research center, a big company, and being a small one. Because of course, for example, we're talking about specific metal alloys, who's making them? Well, to make them, there has to be a small company, probably, or a big one, but if it's small, then of course there has to be all the legal framework that has to help them. Otherwise, we go from the research, which works, but to scale up, how do we do that? So this is my question and food for thought. Thank you.
Excellent question. Believe me, it is one of the most important questions we have today in Europe. Thank you very much. Who started with it?
May I start? Or no?
Yes, please.
It's a really good question, but let's make an analysis of what the problem arises. No? If you put some big company, startup company, and a big company on the same table, the things that we are discussing is intellectual property rights management, how to protect your background, and how to share your foreground. So this means mostly the things that you are discussing. So on this, according to me, because now we are in a European context, my proposal, my way to go ahead is that we have a common approach on this, an European approach on this. Otherwise, we'll never have the possibility to solve this. So, in my opinion, we should create a platform, a project office, call as you prefer, but a way in which we discuss a priori how to manage background, foreground, intellectual property rights in the view to reach the goal. So if we have, as I told you before, if you have in mind what is your goal, what is your final target, then we can solve all this problem. So I guess, at least in Italy, now we are starting to involve many industries in different topics. Sometimes we succeed, other times no. But if we have a common goal, to reach, then you can solve in a simple way also these problems without involving many lawyers. So this is, according to me, would be the way to proceed.
Thank you. Any thoughts?
If I may add something, then I mean, we as national contact point are helping small and medium enterprises also to take care about themselves. I mean, what to look at to be safe during the project, because and I'm sure that other national contact points in other countries are doing the same. As we already had some stories about, I mean, there are some small companies coming to us and telling us that, oh, like a huge industry, they want us to pay so that we will be involved in the project. Do we really have to do this? Or they want us to sign that we will have no right to do things we will invent during the project. Do we need to sign it? So we are always trying to help also SMEs to fit in those projects and to find their good place there. Because I think that it is not possible to go further with innovation without SMEs, as the innovation is quite often there. I mean, somewhere in a garage or like invented between like small group of people who just don't have more money to go to the market. So like projects are a good opportunity for them. They are just need to like feel safe there.
I fully agree. Any more, any other question or thoughts about this issue of collaborating more and more? Yes, madam.
Maybe I can try a question. So, Carole Ballot from CEA, Research Institute for Nuclear System. So I think that a key point of success is also the person. And so I really would like how in your how in your institute you are able, so we were exchanging about that, you are able to convince people to be involved in the leadership of project, because maybe to comment a little bit about what you said, Maria. So of course, in some cases, the project leader, we do have some over here, they really would like to have help from others. But for some cases, there are really people involved and motivated to lead this project, and most of the success is due to that. So we have to attract people, young people or not young. So if you have keys about how to attract people, how you do in your institute, it can help.
I can answer.
Yes.
I need to say that the success of Connect the name is Lorenzo Malerba. So he has all the partnership on his mind since some years. How we motivate Lorenzo, I don't know.
I can't tell you.
No, we don't know, but we support him as organization 100%. So this is very important, to have institutional support to the leader, yeah? And not demotivate him. It's very important. How to do it? I have not the secret recipe. But it's true that the success of the project is 70% the coordinator. And this is a personal aptitude, not a scientific aptitude, I can say.
May I, oh, sorry. May I just add something? I fully agree, it's a personal aptitude, but I think we can grow and build on that. We can just, become a leader in a project. We can construct and build a parcours, a career, and then start as small actions, and then be together with a team, and then knowledge management from the others. So that's only, it's not only a one step. We can build during a few years to become, at the end, I think, having the capacity of leading a European project.
just telling you the story of INOMAT, basically, which is led by KIT, by my colleague Jerry Akhter. We had an internal discussion. It was clear that KIT was basically supposed from other countries basically to lead that project, because we are not basically having own interests as Germans usually in the reactor business. And we had a discussion basically who should lead that. And I said, okay, I'm fully with other stuff. And then we asked basically and tried to convince Jerry Akhter who do that. He at the end did it. And how we did that, it was relatively easy to convince him, even he is mainly engaged in fusion engineering, because we said, first of all, I will support you. So you will not be the only one basically who has to do the work, so you have support from me. And then we had luckily an organization in KIT that's doing all the administrative stuff, because that's what people most basically really are afraid of, doing all the administrative stuff. If you are a coordinator and you can focus basically coordinating the research work in the project, it's a totally different story as if you are a coordinator and you also have to do all the administrative, follow up the reports and all that stuff. If you have someone around, and we have a team of 2 basically people supporting him, that helps quite significantly to support people basically also coordinating projects. At least it worked out in the case of the INOMAT project.
I wanted to ask something, still in the same thing. So in Europe now we see a lot of consultancy companies, and many of the coordinators, they need this. And the problem is that to do your collaborative projects, we spend a lot of money for the consultancy. Is it a solution?
May I start? I think it's not the solution usually, because when I talk with evaluators, they usually say that you can easily notice if the proposal was written by a group of researchers or is written by a consultancy, because usually those written by a consultancy are quite fancy, and I mean, like, they are looking really nice, colorful, but sometimes they are just empty. And it's important to find the balance between something which will be attractive and easy to understand, but still like meaningful. And I think it is impossible for a consultancy to work like alone without researchers. So if it is really like help, then it might work, but never without like a really good group of people who are knowing what they are writing about.
Yeah, I can tell that VTT is selected differently. We are not using consultants companies at all. We totally rejected them a long time ago when we started building our own organization in such a shape that it can carry the things through. And for us, it has been very good because it keeps the knowledge in-house. So yes, it's not a quick solution. Consultants companies are easier to use for that, but in the long term, it's much better.
Yeah, but I believe it could be for the big companies. But we were talking about small companies who are going to do probably single shot or one project a year, or one project in each 2 years.
But if I may continue now, because I see Olli here, and we are talking about ecosystems, and Olli has been one of the leader of these ecosystems, and one of our approaches has been that, for example, SMRs, that now we are trying to appeal even all size of companies to come to work in SMRs in Finland. We established an ecosystem where we invited them to join. I don't remember whether there was a small fee or not, but just so that, for example, VTT and other big companies, we can educate these small companies inside the ecosystem that these are the points where you need to put the focus, and this you can leave to others, so that they are not all the time so afraid that the barriers are high. So we are able to lower the barriers for them.
Gérard Cognier from Nuke Advisor in France. I can give you my testimony because I worked on from different point of view. First of all, I coordinated several European projects a long time ago when I was at the CEA. After that, I was appointed by the European Commission as evaluator of different European projects. And now I'm working for a very small company, an independent company, and we presented recently a European project for which our company decided to recruit a consultancy company to prepare the offer. Of course, their work was very good, but as it was said by Maria, I think quite empty. I had to review at the end the project, and I said, yes, the project is okay. It is Brussels wording, no problem, but from the point of view, from the scientific point of view, there was nothing very attractive, I would say. And this was really, I think, to avoid. But I would say that from the time I coordinated European project and now, there is a huge administrative work to do to present a project, to make an offer. And this is certainly a very high step to climb for a small company.
Thank you very much. So, Marius. Thank you. Benefiting from being a reporter perhaps later. First thing, we were talking about kind of small projects, but I would like to ask about big projects, and I think VTT is here kind of an example, and LDR 50, for example. What I mean by R, D, and I is rather implementation than innovation. So I would like to ask about your experience which touches, in fact, my case here in Poland, where I'm also on some struggle to design the reactor and implement. I would like to ask about the paths for the implementation of big infrastructure, which means a reactor which can be like test LDR 50 or a kind of SMR, I don't know, lead fast or something. Okay, so can you somehow comment on that or give pieces of advice how to cope with that? Because I was, for example, taught that on a European level, my research demo reactor cannot be financed. So, okay, thank you.
Okay, who wants to go for it?
I will try to yeah. When we started working on lead-cooled fast reactor, it was very clear that Europe will not pay for us. Okay, Europe will not construct the reactor. So from the very beginning, when we started to implement the project, the idea was, okay, guys, let's see what we need for doing the project. Because, okay, we start from the idea that we have a good idea. Okay, right? Otherwise, you will never start. But considering that this kind of machine, but this is true for any machine, will solve a problem for us. No? The idea of LFR, fast reactor, was to provide a solution for closing the fuel cycle. So according to that, then we started to see, okay, what we can do with Europe. So in the frame of European project, and as I told you at the beginning, thanks to this European project, we developed several pieces of the technology. We developed some part of the design. We developed some components, okay? And we have developed also capabilities in Europe. No? Now people are able to work on this technology. But then the step is to involve industries. This will be a product that should reach the market in a time frame. So then we can discuss what is the best roadmap or not, but we need the industry at a certain moment, okay? And then the last step, according to me, is that when the project has a certain maturity, you have to build up the condition in most of the member states working on it, that this would be a solution for your country. So this is the case of the IPSEI. Now we are working on this, and there we can get the funding to support, let's say, the design of the machine, the construction of the machine, because the order of magnitude of the budget we need is completely different. European project, we are thinking about a few million for some years, shared with 20 partners, more or less this. When you build up a nuclear reactor, you will have a few partners, few member states, but billion involved in the project. So it's completely different story, no? So if you start your project, consider assuming that Europe will pay for that. Sorry, but you have taken the wrong direction.
Yeah, well, you mentioned earlier 50. It's not in the implementation phase yet, but I can tell you from the Jules Horowitz reactor, which is a huge industrial project and full-scale reactor. It is extremely complicated, especially when there are multiple players and different parts of the reactor design and have been divided to several operators. Like VTT was representing Finland, and we got one piece of the reactor to be designed. In European scale, the challenge comes first of all that we are building a reactor to another country. We need to obey that country's nuclear act. And also in the Finnish scale, we didn't have manufacturers enough. We needed to make European scale tendering process and get the contractors. We got it from Spain. But in overall, this kind of chain of handling the whole process, it's complicated. It's complicated even for Arevo when they built EPR in Olkiluoto 3. They have a huge chain of contractors, but it's more complicated to organizations like we are. We are not device producer or component manufacturers, but still we needed to learn that whole process through. And there's no shortcuts in that. So I fully agree with what Mariano said, that we are facing certain obstacles that we really need to stretch ourselves to go beyond.
May I add just to let's say, to comment myself? It can happen, sorry, but it can happen. With me, happen quite usually. But I want to clarify also this. I want also to stress that anyway, if Europe put more money on the project, it's fine. I'm not against, because when I said you that when I told you that we needed to involve industries, it's true. But industry will come on the table when you have a certain maturity in the project. So you have to demonstrate that the project has reached a certain maturity, that the market is there, no, behind of that door. So for sure, if Europe can put more money on supporting European project, increasing the budget, and so increasing those bits I was mentioning to complement with the project, of course, it's really welcome. So according, in my opinion, we can spend more on this technology. You know, if we want to keep the leadership and blah blah blah, we are the first in the class, but.
Well, but
we are joking.
Even with the money, I add another obstacle. Maybe you forget it in there. Is the dual use. When you are talking about nuclear and you start even importing from Spain or exporting or doing anything in any other country, you have to make sure that you can import it or you can take it.
You're right, for sure.
That's another story again. Yes.
No, simple question. When will you implement your reactor?
Where?
Will you implement? What is the time?
This is a long story. This is a long story. You know, there are I can tell you, I do not come from industry, so for me it's very simple to answer. So it's not my fault. There are projects like Nucleo. It's worth to mention that they are planning to go on the market in 2033 with LFR. And other projects, like for example the one that we are pushing with Ansaldo Nucleare, Raten-ICN, and now with the CK, that is planning to go on the market in 2042, 2045. So this is the roadmap. Different roadmap, different approach, but I guess it's not so far. At least it will come before the fusion.
So on top of the nearly full room here, we also have a massive online audience who has been sending us plenty of questions, and I would like to also pick one from there. This relates to the technology transfer and lessons learned between different kind of big science projects that in Europe we have a lot of fusion and fission research ongoing. On top of that, many other big science projects. Do you have some examples of successful knowledge transfer or technology transfer between this different categories of big research projects? Anyone willing to start this? Free to do so.
I can start, for example. In fusion and fission, if you look on the liquid metals and the protection capabilities of what you do, it's clearly an exchange of technologies. So there are some groups basically working for both partners. There are some groups working explicitly for fusion, others for fission, but the general idea to protect the materials against the liquid metals is not that different. It's a little bit more demanding in the fusion, but I think the general solutions basically are transferred from one to each other. So that's relatively close. And if you go outside of the nuclear world, then again, if you look on thermal storage, there's approaches for molten salts, there are approaches for liquid metals as a heat transfer media or storage media, just basically take the same approaches. You are less constrained about the materials you can use. That's good. Outside of nuclear, you have a much wider variety and a much wider possibility to take different materials. Licensing is not an issue, but the general ideas basically are just transported and put into there.
Any other example then? From somewhere?
Transfer from
nuclear and non-nuclear.
Nuclear or non-nuclear. So no, that's a very important, very important topic. And I would complement there are many transfers in methodologies, and I insist with that. But I think it's important, transfer methodologies and also in approaches. So at CEA, we really have this integrated vision between renewables and nuclear to have this energy mix, the low carbon energy mix. And we really have seen that there are possible transfers for methodologies, simulation, and thermohydraulic calculation. So, because this is the same, this is really the same topic at the end. But to be more concrete, I will talk about this subject for the future, because I think that one of the important topics now is the nuclear for beyond electricity, for hydrogen, heat, and even e-fuels. So, and these are subjects where really nuclear and non-nuclear should work together. And this is really, for me, one of the most important examples nowadays for where we have to work together. Euratom, non-Euratom projects, they have to work on that. Because some of these parts are only nuclear, some are not. So heat, hydrogen, and e-fuels from SMRs or from other low carbon energy are very important topics regarding your question.
Thank you very much.
I have an example of transferability. Materials is a transversal activity per nature. and material working in extreme condition. Irradiation can be an extreme condition, but so on. But I can talk about some example on standardization. For example, a small specimen test technique. Small specimen test technique was developed in the fission and fusion community in the 70s. Now it's transferred to other areas as additive manufacturing, as online diagnosis. And the standardization of the use of a small specimen, for example, the small punch test, was a common approach from nuclear and non-nuclear people. But it was developed in the nuclear business. So nuclear people, we are extremely disciplined in research. And then it is very easy to transfer this discipline, this methodology approach to other areas. And standardization, we can have some examples on small tensile samples. The most important transfer to standardization is the master curve approach. So standardization is a good market to drop our research results.
Thank you. Any other question from the audience? To say something? No, no one? Here we go. Feel free to speak. We are all only between us, a family like.
Hello, my name is Sergei Pugac. I'm from KAPT Ukraine, and I'm national contact point to Euratom in Ukraine. And my question for our panelists concerning culture system, organizational structure in your research institutes, concerning collaboration, research collaboration, creation of innovation. If we look in the past 10 or 15 years ago, can you compare the situation in this area in that time and now? And what is the biggest benefits? What do you think, what helps to do this work better now than in the past?
I can tell you a lot of examples, but I will. Our guests, please.
So the question was about the organization, how it was different then and now.
Yes. So are we evolving in the right direction, or are we going down? Let's put it like this.
In my experience, we are going exactly in the right direction. Nuclear research doesn't have that privilege anymore that we do science for science. We do science for end users and our customers. And this whole customership has become more and more involved in this cycle. When I compare to those days when I arrived at VTT and started my career at nuclear business, it was very few cases when we were really serving the customer. We were just investigating phenomena what we considered interesting. Now there's no time and money for that. Our customers have huge needs, industry has needs, regulators have needs, and we need to listen to them. And in that respect, we have also reshaped our organizations to serve better the end user needs. So we are going in the correct direction, at least in my organization.
Excellent. Yes.
Yeah. I think the context has changed also because 15 years ago we were 15 years younger. And so I would like to start with that because it changed also our point of view. We were perhaps as ourselves discovering on many things. So then we have to be careful of the response because I have changed during 15 years. The context has also changed. Technological context has changed. Artificial intelligence has changed. Information, internet, all these high-performance computing has changed. So these are game changers. Other game changers are, we know better now, or more widely, the energy or climate emergency and the need for doing something now. This has changed. What has changed are also all these energy tension, all the geopolitical situation, everything has changed. These game changers have changed. So what I think that, so how do we take into account these game changers in our research is something very important. That's something we discussed with Erika Holt, for instance. That's something very important, and how we also try to foresee what will be the next game changer. So I'm not answering your question, but this is only first the background that I would like to say that everything has changed and we have to see in advance what will change. So for me, this has changed, and but what is important for innovation, what we had and what we still need to have, is to have deadlines, but also sometimes time to discuss, confrontate it's what we are doing now, confrontate ideas and just say, okay, so this time is also needed for discussion. So it's, I think we are having more and more sense of what we are doing, and innovation is driver for that.
If I may add something, then I do agree with Pedri. I mean, when I was preparing my PhD, like some years ago, there were a lot of professors who thought that the best research is when you like write a long publication, publish it, and put on your shelf. And it's like a line of nice publications. And now I have a feeling that there are more people willing to do research which change something, I mean, which really has an impact. And I think that's a really very good change in this, I mean, this change in this direction is a really good direction. And I hope it will work this way.
I agree.
Thank you very much. Any other question or remark? So then I would like to ask you a question. It is a really stupid question from my side. Sorry about it. If I was young enough, I am, you know, like 20, and I want to do collaborative project, how are you going to attract me to do it? What could be, what is now the driver for me to do collaboration or not collaboration? And what could be my future in this collaboration as person? So according to your experience.
For my experience, I see that when young people come to work with us, it's very simple to involve them. The motivation starts in the right moment that you ask them, what is your idea? What do you think about? Sit to this table with us and discuss together. So they will take profit from your experience, because we are old and so we have more experience, but they are a different approach, different energy. So if you put them in the same condition to work with you face to face and discussing face to face any solution, any proposal, this will be very simple. They will be motivated and they will make a proposal. If you propose them a project that you have to think about by yourself in your office, and then you tell them, this is the project, go ahead, there is no motivation. So this is very simple for me. So yeah, people that are involved from the very beginning will be very supportive and will push in the same direction.
Well, it is not the case.
This is what I see. This is what I see.
In other companies I know. I will not say them.
Yeah, to convince people. I think you have to make the work somehow attractive, so that they are allowed to make their own, basically, mistakes, try to find their own way. My experience is a little different, so usually people expect, at least the young people, if they come for a PhD or master, that you give them a project, so that you have really an idea what they should do, but you should not basically pave all the ways to the results. So there's an objective. So that's basically embedded in a larger project. That's people what they also like. You also have to offer them that they can go to conferences, for example, to present themselves. And you have to teach them that they should do that they should connect internationally with young people. And if you have to basically also provide these opportunities. And then, of course, you have to be there and ready to discuss with them all the time. So if they have something coming up with ideas, that you have also time for them. I think that's if they feel basically, as they see, okay, there's someone taking me serious, of course, giving me the project at the beginning, because usually they don't have the ideas ready, but then you have a good chance that they also stay and not basically just come in and listen to you and then just go away and look for something else.
Yeah, but it didn't mean that they are part of the team.
Yeah,
so they participate to the conference, they make a proposal, they make their own mistake. So they are part of the team.
It's absolutely.
And I think that usually young people, they don't have lack of motivation. I mean, they are usually motivated, so they just sometimes don't know how. And it is like you should start maybe with smaller things, because nobody starts with being like a leader of huge project. So you should see like the clear pathway, and you should choose the people who can be leaders in the future, and they should start with smaller roles and like evolve during the project, and then take bigger roles, and then in the end become like a coordinator of huge partnership or something like that, because you cannot start doing this like from the very beginning. Even, I mean, if you are young, do you think you can? Of course, but you usually cannot.
I can say that European projects are excellent to motivate young people. Why? Because you start to travel, you meet other people, you drink beers outside the meeting.
That's the most important.
And then you start to create your community. So as soon as young people are involved in big consortium European projects or IAA CRPs or whatever, it is true there are two kinds of people who want to be in the laboratory and people who are more social, have more social aptitudes. But for motivation, I think that they need to be involved as soon as possible in a big project. And as soon as possible, she or he has to have some responsibility in this project. This is a very good motivation action.
I don't know how introvert person young Abdu was, but I think that this is actually a very good question in the sense that when people come to work as a research scientist, for example, to VTT, very many of them, they think that this is their own show, that this is my work and I do it. The first thing to teach them is that this is teamwork, and you will never do this alone. And to cooperate in a European scale, you learn to know very many cultures and nationalities very quickly when you step into these projects.
So now to Uli, did you convince you to start making collaborative projects? Because we are the young man here.
Yeah, you can travel, you can have a lot of responsibility. It's very simple.
And have a lot of beers.
Well, I'm currently very happily working at VTT and, of course, open to discuss for further collaboration. I think you are all inspiring leaders and not hard to convince me, at least.
Excellent.
Perhaps, just to add, I fully agree. And with collaboration, we share competencies, but we also share, or at least we have to share, tools or infrastructure. And I think it's also something important to attract people, and that they can benefit from the best apparatus devices. And I think it can attract young people.
Any other, and thank you very much. Any question or remark? Yes. Oh, sure.
Sorry. I'm good at beers, yes, so. And before you know it, if you enter as a young person in such a field, you end up like Mariano and me, coordinating projects, whatever. Anyway, that was not my question. My question was a follow-up on the last comment of Heloise. If you said infrastructure should be available, I would like to ask the question, what kind of infrastructures are you thinking of? What is important for these people to enter the field, but also to do the research?
Oh, for the young...
Basically, so what are we missing?
Oh yeah. It's not, yeah. Okay.
Excellent question.
Yeah, thank you. It was not exactly my point was just that reacting about what you said, that you have different infrastructure and then you build that by part. And there are the offer, Euratom project for this infrastructure. This is very, very important to have that. And with to try to respond with the offer, we we have not complete, but we have a view of what are the infrastructure, which one are aging, which one are not, what are missing. And I think that this offer project is something important, and this map of infrastructure is something important to really know. So that, I don't know, that's a part of my answer, but of course you can...
Thank you. I worked for this project.
Yeah, I fully agree. Probably we have to even enlarge offer for the next. So it should continue, at least that's what I heard. And we have to try to basically be as attractive for the people who offer their facilities, but also for the people to ask basically to travel around and do the research, because this is still not used in an extensive way as it might have to be done.
All right. Any other remark?
Please, then I wanted to add something.
Again, I had another question regarding when you said how things changed in the last 15 years. I was 13, so I cannot say that, but I had a question for the last 5 years. So again, we were talking before about AI and how this could be used in nuclear. Since there are a lot of materials experts here, I had a question because specifically in the last year, IBM Mattergen came out, which helps a lot in the development of new alloys that were not even predicted. Is there any plan to use this within the, let's say, pipeline development? Because of course then we have to do the testing and everything, but at least as a first chance, maybe this could help a lot. And I mean, I see a lot of future, but I'm not an expert in that, so it was also curiosity on it. Thank you.
So may I start? So it basically already started also in the nuclear field. There are lots of initiatives basically trying to combine AI mainly for basically looking for data and then down selecting alloy compositions. We in the Connect and M project, we started with pre-selected projects, so not to have basically just a year of not doing anything. And I'm coordinating one which basically deals with nuclear maps. So there, our effort is to look basically what are all the modules you need to develop a nuclear material and deploy the nuclear material. So we look basically from the design, compatibility testing, aging, all that stuff, and see basically what's outside the nuclear world done in that respect. So really looking, okay, what basically doing the guys on batteries, because they already do a lot with AI, what are doing the guys with PV, they do a lot of combinatorial stuff and so on. And I think we started looking on that, and definitely we have to do a little bit more still on that, because that's the future if you would like to have it or not. But that's basically, at least in looking, exercising and fostering data, that's something which have to come. In addition, of course, and VTT is, for example, strong in that, it's also involved in that map, is automatized SEM-TM analysis, something like that will come, because all these software will be at a certain point able to judge better a SEM picture than you can do that, and much faster. So this is something which will come, and we have to prepare now the databases for all of that. And I think that we are aware of that, and probably we are not the fastest ones, but we have basically understood that we have to do something in that.
Yeah, I can add that within the Entente project that ends last year, we have some trials to use artificial intelligence to analyze surveillance data. And it was amazing. For example, we use a lot of surveillance data for US, France, Spain, and so on. And then we expert on artificial intelligence, because material scientists, we are totally ignore what it works. But they apply some algorithms and they say, okay, this is an example. The most critical factor is the copper content of the RPB steel. And I say, okay, we know that for 50 years. And they answer, yeah, but the algorithms doesn't. So it is a very simple exercise, and also people introduce these algorithms within physics models, and they develop hybrid models to predict enrichment, and it is extremely successful. So we are trying to learn.
Well, maybe I can add a remark. Even I am moderator. I am supposed not to answer, but coming from the industry, I feel I have to answer. Yes, digital is coming in. It is not only for research, it's also in the industry. Digital twins, artificial intelligence, sensoring. Sensoring is the key word. When we will get the right sensor for the right phenomenon to look at, then we will have the right stuff. I am looking at Christophe nearby me. He's our specialist in the digital stuff, I mean, at the European level, you know. But still, yes, there are a lot of stuff. And, by the way, is one of the fields where we are even asked to collaborate with other sectors. If we cannot develop collaboration with other sectors in this field, then we are missing our life. That's what has changed for the last 15 years, if you wish. I know, that's my opinion, but anyhow, any other question or remark?
May I?
Still, we have a little bit of time.
May I
yes.
make a provocation on this? I do agree with you that digital stuff we will need and will increase, but coming back to the question of FAIR, infrastructures. Okay, digital will be important, intelligence artificial will be mandatory, whatever you want, but we can go ahead without an irradiation machine for making material. We can go ahead without an European facility for closing the fuel cycle. What we can do together fuel fabrication for innovative fuel. What we can work together in making the reprocessing. What we can work together to make spent fuel management. These are old concept, let me say old concept, but are mandatory if we want to lead the technology, if we want to enter the technology. And we are missing right now this. We are moving in the right direction concerning some topics, digitalization, intelligence artificial, but we are missing other important parts that are fundamental. When you mentioned offer is very nice, but offer put together facility that belongs to each parties. No? Now, maybe we need to rediscuss some European infrastructures, big European infrastructure. We don't have a fast neutron radiation machine. We don't have at all. So how we can consider to make a fast reactor, we can close the fuel cycle if we don't have a fast irradiation spectrum machine. This is unbelievable. So sorry to make a question from the panelists.
The point is that I think, or at least that's what we see, you cannot separate from one to the other. I mean, yes, digital tools are tools,
yes,
but the hard physics is still needed. Without the hard physics, the hardware, then you are not going to be anywhere. You can still simulate a lot of stuff, but the reality is the first judge. Okay.
I think this three pillars approach with simulation, data, and experiment is important. And the relation between simulation with experiment is not the same depending what you are looking at. Sometimes experiment is in front. Sometimes it's simulation is experiment is to benchmark. So I think we should always have this in mind. And you were mentioning these multi-scale approaches or sensors, that are very important. And also, what is important is whatever is simulation or experimental data, we need to know what are the uncertainties of the data that we have. So, and I think that this is also something important, and perhaps even more important now that we are mixing experimental data, simulation data as training data for AI tools. So we really need to know this uncertainty. So I agree with you, we need to have both simulation and experiments.
Yeah, absolutely, because if you train, let's say, an AI with data you don't know the metadata about, it's meaningless. You will get a result, but you can just take the result and throw it away. And I fully agree. At the end, you have probably not what is meant with a paradigm shift Lorenzo mentioned is not that we really go and tailor the experiments in a more intelligent way than we probably did in the past. So we just don't do corrosion experiments with a variety of temperatures and the types. Probably it might be better to start thinking about, okay, what is the experiment that gives the best output, or what are the experimental efforts we have to do to get the best output of it. This is, first, at time we just screen around. It's very helpful because you can identify things you might miss on the other hand. So it's tricky basically to say what at the end will be the best approach. But because if you just streamline to the ideas, you might basically miss everything around, and you might miss the real problems of the materials. So I think it's not easy to answer at the end, but what will be the best approach at the end.
Probably the best approach will be to have to have both the things, you know. Yeah. I think this discussion. Oh, you want to add?
You need a mic, but you have a lot. I guess yeah.
No, seriously. There was a very important remark made that we have to know what the uncertainties changes. And what Alphonse is basically saying is, what are we doing? If we do an experiment, it has to be controlled. We have to know exactly what is going on. The third thing that we have not touched yet is that modeling also has uncertainties. And not only, which we always think is, okay, there are input parameters with an uncertainty, and how do these input parameters propagate? Another thing that we always miss and never deal with it is what is the modeling uncertainty. The model itself is wrong.
By definition, is a model. I mean, that's the definition of. It is not a theory; it is a model. All right.
We need to know why, how good is actually.
I fully agree. I fully agree, and this is crucial when you. I fully agree when you try to couple different models, because when you try to couple different models, you have input, but you know also how, and this is a very difficult mathematical problem, how you propagate these uncertainties. So I fully agree.
So in principle, the panel was not on science, but you see how scientific we are, how technical we are.
Oh,
We are excited as soon as we start talking about simulation, modeling, infrastructure, and all this stuff. But actually, how to make this all what you are talking about happening at the European level? That is the question we have in the panel. How to make it? And I think we have 5 minutes to answer this question. Can you give it a try? How to make it then possible? All what you said is fantastic. How to make it?
That's a very good question. This is always the way to start when you don't know what to say, right? The problem is that the same discussions are in many different fields of research, and there's never enough money to fund everything. And so we need some compromise, and we need to, but it is really difficult to decide if it is more important to fund nuclear research or health research or transport or whatsoever. So probably if we will have like a room full of health scientists, they will say that, of course, like health research is the most important, and like nuclear, that's not the thing we should be funding. But so we need to find a balance, and of course this compromise is pretty difficult, as when we talk with different countries on the topics and on the content of the new programs, it's pretty difficult to find the balance because, for example, I mean, something outside of nuclear research, when we talk about offshore wind energy, then you can imagine that there will be pretty different position of Denmark and of Austria thinking if offshore wind energy is important. So it's the same like with different point of view of different parts of nuclear research. And finding this balance is pretty difficult, and finding this compromise is pretty difficult. But I do hope that next framework, that this framework program and next framework programs will bring money for research which will be interesting for you. And we are talking about success stories, so I hope that next success stories will be your success stories, as I'm sure that in this room there's a bunch of great ideas which can be evolving into new projects.
Excellent, thank you very much. That is the best conclusion probably, unless someone wants to add something.
No, I agree, and in a simple word, we needed to remove unanimity in the votation in Europe, because otherwise we'll never move.
Yeah. Thank you very much. Thank you. So we end up here. Thank you very much. We are 3 minutes behind.